Does this mic work? Okay. Hey, I'm Jen Giardino. I'm a user experience designer at Red Hat.
And I'm Vince Gonzola. I'm also a user experience designer at Red Hat. And both Jen and I work on a product called Red Hat OpenShift AI, or ROI, as it's also known. And ROI helps organizations doing AI manage the life cycle of the models they use, everything from model training and customization through model deployment and monitoring models in production. And our primary users are data scientists, ML ops engineers, and app developers slash AI engineers who are incorporating AI models into the intelligent applications that they're creating. Rory runs on top of OpenShift as an operator. OpenShift is Red Hat's productized Kubernetes offering and can run anywhere from public clouds to customers' own data centers. Just so we know who's in the audience, and I think I know the answer to this probably already, but how many of you are familiar with open source software and how open source communities work? Okay, you all probably know a lot more about it than I do, but just for the sake of the recording, just talk briefly about difference between upstream and downstream. Upstream is the source repository, usually in Git, and it's a project where contributions happen and decisions are made. It's where all the code is created and managed, and it's where it's stored before being used by other products. And contributions flow from upstream to downstream. And by downstream, we mean the projects or products that use and modify the upstream code. By an upstream community, we're talking about the people. They're the people, mostly developers and other users, who maintain the code and collaborate to govern and contribute to the project. They're responsible for making key decisions, reviewing the code and maintaining it, and setting the direction of the project and making sure that it's healthy and flourishing for all the other users who use the code that they're creating. For Roy, the immediate upstream project is called Open Data Hub, or ODH. And like Roy, it's also packaged as an operator for OpenShift or Kubernetes, and is a platform for managing model life cycles at scale that run across hybrid cloud environments. ODH is the project in which all of the code is developed, and then it's productized with Red Hat branding in Red Hat OpenShift AI. And while it's an upstream project for Roy, ODH isn't a really truly an upstream project because it integrates a number of other upstream components into a single platform. In fact, last I knew, there were at least 30 upstream projects, and it's probably a lot more than that now, that provide components to ODH. So we consider ODH, from the Roy standpoint, we consider ODH a midstream project. And of those 30 plus projects that contribute to ODH, one of those is called Kubeflow, and that's the project and community we're going to talk about today. Kubeflow, it's an upstream project, and it provides several components that get integrated together into the ODH platform. Like I said, ODH is the midstream, and then OpenShift AI is the downstream product. So a little bit about the Kubeflow community. By open source standards, Kubeflow is a fairly small community with around 150 members and 2,000 followers. By comparison, the Linux kernel community has over 11,000 contributors from almost 1,800 companies, and it's been forked over 57,000 times. Kubeflow is made up of 7 sub-projects. There's Kubeflow pipelines for automating the workflow of open models, AI/ML models. There's Kubeflow notebooks, similar to Jupyter notebooks. There's a central dashboard, and then there are also components for model training, automated machine learning, model serving, and there's also a model registry. And model registry is what our story is about today, how we engaged with the Kubeflow model registry working group within the community on a research project. Take a quick sip here. Oops, sorry. So you can think of a model registry as the bridge between model experimentation, customization, training, and then model running in production to be consumed by AI applications. It's a central index or database for managing the life cycle of models, their versions, and also their metadata. The primary users of a model registry are data scientists who are doing the development of the models and evaluating different versions of the models as they're doing the development, and figuring out which is the best model to use. MLOps engineers, they use the model metadata to configure deployment environments to make those models available for evaluation, and then to deploy a champion model into production environment. And finally, business analysts use model registries to monitor deployed models and their performance and outputs to make business decisions. Now Jen is going to talk about the research project we initiated with the Kubeflow model registry community.
Yeah, so as UX designers, one of the things that we support is user research. And when we were discussing UX improvements we could make to model registry, we realized that there were some research that we should do. So revisiting Vince's previous explanation for what a model registry is, it allows for the management of models and versions and their associated metadata. And we had some previous user conversations that produced some insight that the navigation path to a model version was challenging. But we had different opinions about how to solve that usability issue. So to provide some context for the UI that we're talking about, this is the model registry landing page. You can see it's a list of models. And if I click on a model, it takes me to this page, which then shows a list of versions. And then if I click on a version, I then see a page that shows the metadata for that model version. And we believed that this was the object that people cared about the most because it's the artifact that the data scientists are creating. It's the artifact that the MLOps engineers are deploying. And so if we step back, you can see the full flow of the list of models going to the list of versions and then going to the version metadata. But then there's also model metadata, and that's available from the model details page as well. And maybe that's also important, but we weren't really sure how important that is relative to the version and the version metadata. But the suggestion that was being made was that we should just go directly to the version page with the version metadata, specifically the latest version, because now the user would have fewer clicks to get to that object that they cared about the most. But as we discussed this idea, some of the questions that come up were, do users really only care about the latest version? What if they need to get to another version? Would the new flow make it more challenging to find previous versions of the model? And really, how important is the model metadata? So this is where user research comes in. Research lets us test these flows to understand what's important to users and why, so that we can make those UX decisions with more confidence. So Vince is going to talk about what we did.
All right. So there are different types of user research that you can do, and those different types require different techniques. In this case, we were doing design validation research. We wanted to validate the assumptions that Jen talked about the latest version metadata being the critical objects that users cared the most about and that users expected and desired to have a shortcut navigation path to. So we created a research plan to test our assumptions and answer questions about how users actually navigate through the model registry UI. The second thing you need when doing model research, once you have a plan, is you need research materials. And when doing research, you can do validation research, especially with lots of different kinds of test materials. Anything from hand-drawn sketches to fully functioning software applications. Typically, the more specific the research question is that you're trying to answer, the higher fidelity of materials you want to use. In our case, we decided that an interactive prototype that simulated the proposed navigation pattern, the shortcut from the model list to the model version details and metadata, we decided that a prototype that simulated that proposed navigation pattern is what we needed. So one of our colleagues created a prototype of that UI in Figma. The third thing you need when doing, the third thing you need when doing research is participants. And one of, if not the biggest challenge when doing user research for enterprise software products is finding qualified participants. So if you're doing research on a consumer application or a streaming service like Netflix or Spotify, if you're doing research on their UIs, or on a consumer-oriented application or website like Airbnb, the pool of potential participants is huge. It's almost unlimited. There are millions and millions and millions of people who use those applications. But when researching enterprise software, which requires very specific skills and experience, the pool is often quite small. And this is especially true when doing research in emerging technologies like AI. So for our study, we decided that we specifically wanted people who had experience or at least familiarity with using AI/ML model registries. As you can imagine, finding people like this was like looking for a needle in a haystack. So we decided to engage the Kubeflow community to try to recruit participants. Almost by definition, members of the community, and especially members of the Model Registry Working Group, fit the participant profile we are looking for exactly. They're working in that space, so they should be familiar and have interest in providing feedback on the designs for those areas. So enter Eder Ignatowicz. Eder is the UI lead for Model Registry and Notebook working groups within Kubeflow, and he's also the lead for the Model Machine Learning Experience Working Group in Kubeflow. And he also happens to be an engineer on the Red Hat OpenShift AI team. So it was perfect, very, very lucky for us that he had those deep connections into the community. So what we did was, working with Eder, we first created a screener survey and a self-scheduling calendar. So the screener survey was to make sure that people who did sign up for the research had the background that we were looking for. So we asked them about their experience using model registries and how familiar they were with them. And then through Eder, we were able to attend the community meetings for first the Model Registry Working Group. And we were hoping that we could get a number of people just from that group, because they were really the core participants that we wanted. But because of the time of the year we were doing this and some other factors, those meetings weren't really hugely attended, and so we didn't make much progress there. And so our next step was to go to the larger Kubeflow community meetings. And I think you presented there, talked about the research we wanted to do and how we needed participants and how it was important for the community as a whole. So we presented there. Eder also got us mentions in a couple of blogs that are available on the Kubeflow website for community members to read. So we publicized or promoted the study through blogs, through attending meetings, and then finally, Eder personally invited some members of the community who he knew would be good fits for the type of people we were looking for to participate in the research. In the end, we got about a handful of people, which for the type of research we were doing was probably sufficient. It would have been good to get a few more. We augmented those with a few Red Hat people who were familiar with model registry and model registries in general, and so we got enough people to complete our study. And Jen is going to talk about the study itself.
Yes, so while we were working to recruit users, we were also working on preparing our materials for the study. And For one of the research questions we had, the one that I described earlier, we decided to create an interactive prototype. Testing how users interact with the prototype would let us understand their expectations when navigating between these pages. And with a prototype, we can observe what they click on and ask if the page they see matches what they expect to see. But then, because we wanted to have participants from the community, there were some things that we needed to consider when we created the prototype. So we know the Kubeflow community members are not using OpenShift AI, and they also aren't using the Open Data Hub version of the Model Registry UI. They use the Kubeflow version of Model Registry, and there are several differences between this UI and the one that we typically are designing for Open Data Hub or OpenShift AI. So one of the main differences is the navigation panel on the left, different set of pages, different look, and then there's also different branding in the Kubeflow version of the UI. And they use a different design system, so the styles look different from what we typically use. So when we were creating our prototype in Figma, we considered those differences. So for the navigation, we just blurred it out. It wasn't necessary for our test to have a completely different navigation from what these participants would be familiar with, and it isn't worth wasting the time to have them focus on that during the session. So the simplest thing to do was for us to just blur it out so it's not an area that they would focus on during the sessions. We also removed the branding from our prototype. So it still looks more like the Open Data Hub or OpenShift AI version of the UI, but we did not include that branding in there. And then the styles, we ignored the style differences. For the amount of time we had to prepare these materials, we didn't really have time to create a new design system that matched what the Kubeflow community members were using. And we weren't really concerned about that aspect either, because we were testing the interaction patterns, and those would be the same between the two design systems that are used in the two projects. So then we created that prototype, we ran our research. We had other activities that we did during the research sessions, but when we were done with the research, we did want to share the results of our research back with this community. Because this was our first time engaging with this community in this way, and it's something that we want to be able to continue doing. And so for them to understand that if they participate in this research, there will be something that comes out of it that gets shared back to the community is important for them to know, so that they are inclined to volunteer in the future. So at this time, we had a researcher who was available to help take the findings from our sessions and the transcripts and produce a report for us. And so we had a researcher on our team, Mark. He created the report. He shared it internally at Red Hat. But before we could share these findings with the community, there were some things that we needed to change with that report. So one you can see obviously is the theme and the slide deck is different. The one that our researcher created is based on the theme that we use for our internal presentations at Red Hat. But we wanted the theme of the report we shared with the community to reflect that community branding. But there's also another aspect that we had to consider when we shared the results with this community. So when a UX researcher shares results internally, they're presenting them to the product management team, engineering, and also designers. And they're providing recommendations that designers would then incorporate into the next iteration of the designs that they're creating. But as Vince mentioned, in the Kubeflow community, that audience, they're primarily engineers. And so providing them with just a set of research recommendations, it's not very actionable for that audience. So for this report that we created for this community, we also took the design recommendations that our designer pulled out of the research recommendations, and we included those as part of the report so that this community would have something that is much more actionable for them and incorporating those recommendations into the next iteration of the UI. And so once we had that report ready to share, we joined a community meeting to share those results. And again, this is where having those allies already in the community to help guide us was really helpful. I think at this time, Eder was on PTO, but he pointed me to a few other individuals at Red Hat who were also very active in that community. And they were able to help me figure out which would be the best community meeting to attend. I think over the summer, it's just some meetings don't get as much attendance, so I ended up sharing it at the broader community meeting. And then also, after sharing it at the meeting, they have other places where you can share things with the community. So the Slack channel, I shared a link to the slides there and described the work that we had done. I also shared it out on the community mailing list. And so, as I mentioned, this was our first time doing this type of activity. We learned a lot in doing this, learned a lot from the allies that we had in the community. And there were definitely some takeaways that I had that I think are worth remembering and also just passing along to other people in my team, just so that as we start to engage in this more in the future, that we kind of keep these things in mind. So one, obviously, is just knowing who your allies in that community are. They're super beneficial to any newcomer. It takes a lot of time to foster that trust and those relationships with the upstream community. And so if they've already developed those, then they can help you with knowing how to navigate that community. The other thing is knowing your audience, which I think as a UX designer, that's a pretty basic thing that we do anytime we're creating anything. It's knowing who are we creating it for. But it was something that kind of came up multiple times over the course of this effort, as we're creating the research materials and as we're presenting the findings back to them, just understanding who we were engaging with and how they might react to different materials differently. And then obviously community is all about contributing back. So we learned so much by engaging with them, but it's important for us to also then share what we learned back to the community as a whole. So that's it for our presentation.
Any questions? Yes.
Did you face any opposition or sort of resistance to any of the in the community? And if you did, how did you kind of navigate around that?
Would you like to repeat the question?
Okay. So the question was whether we faced any resistance from the community to our involvement. Is that?
Yes.
I would say not, but Eder did a really good job of warning us beforehand, of making sure that we weren't making it clear that we weren't doing this research for Red Hat, that we were doing it on behalf of the community. And so that's why Jen stressed the importance of like taking the Red Hat branding out of the materials we used and things like that, just so it looked like it was apparent that we were doing it for the community. I think if we were to do this in the future with other communities, and hopefully we will, we should really try to get involved in the communities earlier, not just like show up like, we're here, we want to do research for you, but actually start attending community meetings earlier, getting to know some of the members.
Yeah. I mean, definitely the things that we talked about, the things we did to make our prototype suitable for the community and the report suitable for the community. A lot of that was just Eder's advice on don't include branding, but also like you have to include your designs with the research.
Any other questions?
Yeah.
Thanks, Kevin.
Okay. Yeah, I was curious. Were any takeaways from this research? Was it used to inform the changes that are going into Open Data Hub as well as data science, or does it also feed into Kubeflow UI itself? Like, so I guess how do you end up using this information, and which one of those product or projects did you influence?
Yeah. So the
Remember to repeat the question.
okay. Kevin, can you repeat the question? What's the short version of the question that I can repeat?
Thank you. Thank you very much. No, so yeah, just very short and sweet. Given the takeaways from the research, which one of the projects did it end up influencing? Was it Kubeflow, Open Data Hub, or OpenShift AI, or maybe all of them?
Yeah, so the engineering team, specifically the front end team, is actively working on getting the UI components implemented in the Kubeflow community. Because I think right now there's some a duplication of UI development, and the goal is we build the UI in Kubeflow, and then we consume it in Open Data Hub, and then we consume it in OpenShift AI from Open Data Hub. So I don't know if you were in a recent meeting, but I did see one of our UI developers demo the Kubeflow version of the UI. And I should have probably included an example of that here. I think I did and then deleted it for time. But yeah, it was really cool to see at least the Kubeflow version of that UI based on the design recommendations there.
The timing of the research was kind of interesting because while we were doing the research, it was at the same time Model Registry hadn't been being developed upstream yet, and they were going through that process of changing from downstream development to upstream development. So our timing, I guess it was either really good or kind of, I guess it was really good because we were a little bit ahead of them, so they were able to incorporate those changes.
Yeah.
Pretty much all the development for OpenShift AI is done either at one of the upstream communities or in ODH. Nothing is developed purely for OpenShift AI.
Yeah, I think that's pretty important to really emphasize. I think you guys did a great job around that. We're building for the community, not it's not for the purpose of Red Hat. It's trying to develop or improve their experience, and if that benefits other products, that's a good thing.
Awesome. I think you were saying earlier when we were talking that that's something we want to try and do more widely on our product.
Yeah, so even just with Kubeflow, there are other components that we're, I think another one that we're actively trying to engage with them on is the notebooks work. And then, I think that's kind of the other thing that we've been doing quite a bit of this year.
Any other questions?
Have you found that this effort has resulted in any of the engineers, maybe at Red Hat, who have then connected to the upstream community and have stayed as members in the upstream community?
Engineers, not that I know of. I mean, Eder was already involved. I think, were you talking about Mike, the UI developer?
Mm-hmm.
Yeah. Mike has become, within the last month, I think he's now a contributor to the community. And I think there's a few other members of the Model Registry development team who are now on their way to becoming members of the community. They're not contributors yet. I think they're reviewers.
Yeah, I saw a few team members as contributors.
Okay, that's great. Yeah, and from UX standpoint, I try to attend the meetings when I can, the community meetings, but it's not always easy.
So I just have a question. How do you get started with the Kubeflow community? Where do you find them? Where do you?
They have a Slack channel, right?
Yeah, so they have a Slack channel. They have a web page. I mean, you could Google it and find their web page that talks about the community. Like they have a community calendar that lists the different meetings that they have. So I don't have a link to that page in the slides, but I can add it and update that in the slides that we share.
All right. Thank you.
taking your spot. You good to go? All right, so left of this table. Alrighty. Oop. How about now? All right, so introducing our next speaker, Karen Fanan. She's the co-founder and CEO of MyOp, a developer-first platform transforming how UI and UX are built, controlled, and optimized in production. Karen has held key leadership positions at Moon Active and Get, and has a proven track record of success in scaling startups, launching strategic partnerships, and driving profitability. And today she'll be talking about, is front end still a thing?
Great, thank you. I think I have this mic, right? Okay, cool. Great. Hi, everyone. So in this session, we are going to talk about front end in the age of AI. We're going to dive into what AI can do and can do actually very well, but also what it can't. And I'm going to use some examples from companies that run with AI coding in production, and I believe it's very, very interesting to learn from that. Let's see. How do I, oh, sorry. Yes. So my name is Karen Fanan. As mentioned, I'm the co-founder and CEO of MyOp. MyOp is an open source library and a platform that connects externally generated code, mostly by UI, directly into live enterprise software. So over the past 15 years, I have been working in tech. I started as a product manager, I then became a general manager, I was a VP of product, and today a founder. But the reality is that no matter the title, I always had the same job, a professional beggar, begging developers to build my ideas. Because that's the thing, if you're not a developer, if you're a product manager, a designer, even if you're a senior leader, you always need to have a developer fulfilling your ideas and making them a reality. And that's why AI is so exciting, because AI basically means I no longer have to beg, right? AI gives me something that is called agency. Agency is basically an extension to our working power. I can today code without knowing how to write code, right? That's super cool. So the ability to do more with less friction, that's what AI is all about. And that's why for people that are non-developers, that's super, super exciting. So I want to start with an example of a company called PickTime. So PickTime is a platform for developers, for photographers. We're here to talk about developers, but that's not the case. Platform for photographers, they exist for more than 10 years. They have tons of features, and their entire purpose is to help photographers to sell more. And they're quite successful in that. Oh, sorry. They had a case, a feature in their app that exists for something like 3 years, where the photographers can sell albums to their users through a pricing calculator. Their customers did not like that feature at all. The entire social network was full with complaints about the feature being super complex. Sorry. Complaints about the feature being too complex and about user not being able to use this feature whatsoever. So their designer reached out to Lovable, right? That's not new. We all know Lovable. There are many kind of prompt to design, prompt to web tools, and wanted to get an inspiration to how to fix that. With a simple prompt, the result was quite amazing. Lovable suggested a whole new way to build this tiered-based pricing calculator with discounts and everything. Lovable suggested to have a chart, something that they did not have before. So here, nothing is new. We all know that AI tools are first and foremost great for generating new concepts for existing features or even for new ones. Beside Lovables, there are a lot of other many tools. They tried all of them. The results were quite similar. I guess you know why. Most of these tools, Lovable, Bolt, V0, etc., they're all based on 3 leading models. We have OpenAI, we have Anthropic, we have the Google model. We also have DeepSync, but these are the most common 3, and this is why no matter which model you use for concepting, you will most likely get similar results. So in this case, they decided to continue with Gemini. So I have a concept now, but now I can take it with Gemini to build an actual prototype. So I'm no longer just asking for inspiration. I'm now prompting Gemini to build an actual HTML, CSS web page for me to have a working calculator, tiered-based calculator. And that's what the work with Gemini led us to. So now we have a new pricing calculator with tiers, with discounts, with checkboxes, with chart on the left, and all of that was built with Gemini. So it wasn't an easy task, right? The PicTime designer who worked on that feature had to go through back and forth with the chat to get to that result. The thing here with prompt engineering for non-developers is that it's not that complex. If you talk to the model the same way you talk to engineer when you want them to develop that, the results are quite amazing. So we had that back and forth, and we ended up getting this prototype. The team then actually took that prototype to their beta customers. They have some photographers that could see the features before they go live, which is also super cool because now I don't have to build this manually in Figma. I can use AI to do that, more feedbacks, and we have it. So let's take a look. A complete pricing calculator, tier-based, with discounts, all created end-to-end, inspired by Lovable, built by Gemini. We have tooltips here, checkbox, and everything. I think that's amazing, right? I mean, not a single line by a developer, all built with AI. So what's next? I think I'm not saying anything new, right? I mean, we use AI tools for concepting, we use AI tools for prototypes. In any normal company, the next stage will be to take that prototype to a developer for inspiration, and then developers will start and build that from scratch. But then we didn't really bring any change to the world, right? All of the AI buzz about anyone could build, about agency and stuff, and we end up building prototypes that eventually goes back to developers to build them from scratch, and may meet production in 2-3 weeks, depends on how fast they move. And I think the interesting part, and that's what we are here to talk about, is can we take these prototypes to production? Because behind that, there is a code that works. It looks great. It's built by AI, but by a machine, but that's also fine. And if we can do that, that's a whole new level of development. So in order to answer that, we actually have to dive into how feature works and the technology behind them. So the reality is every single feature that we work on is built from 2 distinct parts. The first part is the generic code. The generic code is basically the layer of code that is very common. I am referring to the user interfaces. I'm also referring to some basic GUI logics, animations, hover states, maybe drag and drops, scrolls, etc., etc. These things normally exist in any app that we know, but they are common because hover state is a hover state, and scroll is a scroll, and animation can be more complex, less complex, but it's the same thing. And interfaces mostly are obviously built with HTML, CSS. That's also quite generic. The second part of the feature is a proprietary knowledge, and that is the opposite of generic, right? That is exactly the secret sauce, the very IP specific internal knowledge that each company has. And for that, we also need a very experienced engineer to be able to build that. These engineers need to have to go through an onboarding in the company and to know the exact specific area, whether it's fintech, mobility, whatever. So every single feature contains both. And what we discovered that is quite interesting, that in many cases, the generic part takes the majority of the development time. So if I have a complex UI, a beautiful screen, crazy animations, that could take weeks of development, although it does not require anything very unique from the developer. It just takes time. And the proprietary knowledge takes 20 to 40% of the time. And that's exactly the opportunity that we believe AI brings to the table. So back to the example, we worked with the Gemini. We have this tiered-based pricing calculator, much better than before. We have a working code. Now we need to connect this code to the already live working application, right? So there are a couple of ways to connect it. I can also always do a manual integration. I still, I have this code from Gemini. I can copy, paste it, and put a developer to start wiring the refs and props. It can work. It's also possible to use MyOp, which is my company. It's an open source, as I mentioned, open source library and a platform that does exactly that. There are other solutions in the market. But the idea is that for non-developers, designers, product managers, to actually build what used to be just prototypes with AI and then copy and paste them into the MyOp app, MyOp turns the Gemini, Claude, whatever code into a standalone component that then can be connected. The next phase will obviously be to release it to the users. So that could also be with A/B testing, gradual rollouts, or segmentation. So first we give it to QA, early production, and so on and so forth. And with one click, it's live. So now back to the PeakTime app, their users, and I'm talking about hundreds of thousands of photographers using this platform every day. They go to the app, they click on that pricing, and they get a designer-made code with Gemini, of course, live in production. Just like any other feature, they promoted a Facebook note about it, and great responses, great feedback. Users are happy. I can share that after they went live, they have received some feedback. So the same designer that built that feature went back to Gemini, prompt the AI to make changes, copy paste to MyOp, publish, and it's live. So the entire cycle of feedback, changes, making things better no longer has to take weeks, right? It no longer has to compete with a lot of other features that we have in the pipe. So just to look on the new development process, okay? So, and that is, of course, a suggestion because there are so many tools for each stage. So we make the concepting and the design with Lovable, Bolt. There is also Base 44, Figma Make now working extremely well. We then use one of the models, Gemini, Claude. Maybe in the future also OpenAI will get better in generating code to generate the actual code. We then plug it into our working software because that's the idea to make it live in production. The developer, the front-end developer, works on the internal logic, on the data structure, on the actual connection, and we have features live in production. The interesting part here that I think that the real innovation that AI brings into tech companies is that if we used to have the full stack developer, which is front-end engineers now becoming full stackers, also doing some back-end. The reason the full stack engineer is more powerful than the front-end engineer is because there is less friction, right? The front end is less dependent on the back end, can do more. The same concept works for designers and product managers. They can now do more with AI. So a designer is not just designing, is actually handing off HTML, CSS, pixel perfect to the developer, and same goes for product managers. So the way we see the future of development with AI is that the front-end engineer becomes the full stack engineer working on core logics and mostly on the architecture. And the full stack designers and product managers are the one not just to design and work on specs, but actually building UI code and taking that all the way to production, but also doing experimentation, optimization, and closing the loop from the user back to the code and back to the user a lot faster than before. So back to the opportunity we talked about. The main shift that we see in responsibilities is, as I mentioned before, front-end engineers using copilots or not, completely up to them. I'm in favor of these tools. Working on the more complex things and validating them internally, but everything that has to do with the generic code, the UI aspects, the GUI logics, the things that are quite repetitive in a lot of the apps that we know and we see will be offloaded to the citizen developers, the full stack product managers, the full stack designers working with vibe coding tools. And all in all, what we're going to get is much better products and faster development. The next question is, how do we split basically between the engineers, designers, and product managers, who owns what? So for that, we created a model that is called the OEW. That model helps us and is expected to also help tech companies to decide for each feature how to split the responsibility. So O is for onboarding. How easy it is to understand that part of the code. Okay, if it's quite simple, then it's easier to offload that part to citizen devs and vibe coding tools, right? If it's very complex, if I need now to sit with a person for a whole week and bring them up to speed in order to develop that part, then it should probably stay with engineers. And one more critical thing here is the ability to validate the code, right? So if I'm building an interface and I can see it and I can validate it, that's great. If I'm building an internal logic or functionality and I have no way of knowing if the AI code makes sense, that's a problem. The second thing is exposure. How deep is the exposure to the internal IP, to the internal knowledge, to the internal concept? The bigger the exposure is, the more likely that piece of the code to stay with engineers. If the exposure is light, again, makes sense to offload to vibe coding tools. And then the W goes for who. After we have an answer to the onboarding, we have an answer to the exposure, we could decide who should own that part of the code. Again, whether we leave it to engineers working with Copilot tools to develop faster the logics and functionality, or we offload it completely to vibe coding and citizen devs. Let's take an example. So we had that calculator. So of course we talked about the UI, we talked about the GUI logics, but we also have the discount logic. That is an internal model from within the company that build a tiered-based discounts, depends on the type of the type of photographer, etc., etc. So that is quite complex onboarding, very high exposure to the internal knowledge and data of the company. So we will keep it with the engineer. When we talk about the interface, when we talk about the documentation, these are stuff that can be handed to designers, product managers. Okay, so this is how we basically build it. All in all, I can share that features that work according to these to this model can lead to 80% savings on development time and speed, which is insane. Okay, so a little bit more examples, and tips. So after that initial calculator, the same company, and I really find it to be mind-blowing, released 7 or 8 more projects. Very complex UI heavy, logic heavy features that were built by AI coding tools combined with internal and logic built by engineers. So we talked about the combination of Lovable for concepting and Gemini for the code. Sometimes Gemini doesn't work. I mean, you want the screen to look more pixel perfect to the brand. You have a Figma that you want to be close to it, and it just doesn't work. In this case, they also tried to upload CSS to the Gemini to make it pixel perfect. The result was not good enough. So there is Figma Make. I don't know if you've heard about it. I guess you have. So Figma Make actually helps with both concepting, but it also allows us to take the code behind and upload that into one of the models, Claude or Gemini, to create more pixel perfect results. There are also tools like Anima, Builder.io, that sits exactly between the Figma to the code in a more pixel perfect way. From our experience, you normally still have to copy paste that into one of the models, Gemini or Claude, to get the full kind of code ready, including some logics, and to have a working prototypes. So in this example, the way they made it happen is that they took the screen that has a lot of tiles, they focused on one tile. The more you narrow down the problem to the AI, the results are better and more pixel perfect. So they perfect the one tile and then implemented the same style on all others and created the full screen. Each and every tile has behind it data and some information from the internal kind of database of PickTime. But the thing is that the entire UI was created again with AI. After an internal round of feedback, the marketing team wanted them to change it again. They went back to the model, back to having a pixel perfect screen. And why is that important? Because today, these entire cycles normally means that we have a developer working on some component, building it. We like it, we don't like it. It's not like the design. There is a lot of back and forth. And here, this entire cycle with AI tools bring us to a pixel perfect HTML, CSS without the developer in the picture. And that frees developers to work on critical things. What else we could do with AI? Of course, documentation and QA. So after we have a working prototype, it's quite easy to prompt the AI to build us a complete documentation and even a testing kit, which is quite cool, like you could see here. And also, in some cases, I guess you all know that you work with the chat on something, back and forth, back and forth, back and forth, and at some point, with everything you add, it breaks something else. So, so you want to add something to your component, but then something else breaks, and that's really annoying. So some things that we found to be helpful is to ask chat to find a way to make Gemini or Claude fix the issue. So here we ask chat to help us fix an issue with Gemini. He was happy to suggest a prompt for that. We copy paste that to Gemini, who of course apologized for the mistake, and we have a solution, which is crazy. So I think the most interesting part is in features like this one that has, the video is cracking a bit, that has extremely complex visual animations and behaviors that normally takes a whole bunch of time. And believe it or not, but with the right prompting, AI actually created all of that. So I think the key insight, besides what we could do with AI, is the understanding that AI is not just a tool, it's becoming another resource on the team. And because it's another resource on the team, it means the change is not just technical, but it's also organizational. So working with companies, what we see that there is a whole new layer of human resources. It's not just the human management, it's the AI resource management. So even for HR people, they need now to manage a whole new bunch of resources, which are the way we use these AI models. I'm gonna run through some concepts that work really well in some companies. So if in the past we had squads of developer, designer, product managers handing off stuff from one to the other, we now have all of them prompting the AI to generate code together. It's quite helpful when they all work on the same account, actually. The same way that teams do weekly meetings together, we now need to have AI weekly meetings. In AI weekly meetings, we actually go through the output of the AI and discuss what worked and what didn't work, okay? In order to implement AI coding in working production environment, we need teams to communicate more, to collaborate more in order to make this thing work. So dedicated AI meetings, that's a part of the drill. And the last but not least, ownership. One of the things companies talk about a lot is if I'm not writing the code, let's say if a designer or product manager is prompting Claude to generate code and it's get to production, who owns the code if something goes wrong? So the rule we found to be working quite well is that if you generate the code, you own it. Okay, and this is why it goes back to what I mentioned. You better be able to validate what you're doing with AI. But with these concepts, we can actually see companies already today, and I'm talking about companies with hundreds of thousands, with millions of users that use AI coding tools in production. And some of the people that are shipping this code are not developers. And if you would say that 2 years ago, 3 years ago, people would think we are crazy, right? But no, it's working today, and that's basically the future. So just recapping on the rules. Number one, AI is agency, is extension of our human power, and I think each and every one of us needs to think, what is the agency that AI gives me? Number two, if you work with AI, validate it. The same way that you won't give, I hope, AI to write an email answer for you without even reading it. That goes back to code as well. Number three, it's not a tool. It's a resource. It's a teammate. It's something that joins the way we work on the day-to-day. And when you understand that, it gives you a lot of power. That's it. I don't know how many of you already work in companies or is going to start, but I think it's a very, very interesting era to start working in tech with the AI tools. I think it's completely different than what we saw years ago, and it's all because of AI. That's it. I will have 6 minutes. Sure. Any questions? I guess it was all very, very clear.
Maybe I'll ask a question. In the list of OEW that you shared earlier, where does security or compliance, those kind of things feature? Because that's a lot of domain knowledge, and if you've been a seasoned developer for 5 years, 10 years, you develop that over that period of time.
Yeah.
How does that feature in something that's done within that query?
Yeah, that's a great question. So the question around security. So I think security and AI, that is one of the kind of major challenges, regardless of the tool that you use. Okay, I was here referring to external tools that you work with and then copy, paste, or plug the code to production. But we also, of course, have the cursor and copilots and all the models that run on the code and generate more code. And there is the question of security as well. So in general, when we want to embed kind of AI into our coding, there is a question of security. Luckily, a lot of people are now handling that exactly. In our company, when we plug externally generated code into live production, we keep it in isolated. So it's basically in isolation from the core code. We create a communication that is safe, but we don't embed the code. So that's one way of dealing with security. So I'm saying, okay, if it's what's written by AI and not by a seasoned developer, then I'm going to keep it out of my core code base. So that is one way. I can say that there are a lot of solutions also for the cursors of the wall that run on the stack, and they are embedded into the code. So there are ways to handle that. I think that the OEW refers more to how do I know which part of the code can be offloaded not just to AI tools, but to AI tools and non-developers. So I'm talking about the external tools. They don't have the context. They don't have access to the repo. They basically know nothing about my company. When PeakTime, when their designer went to Gemini and prompt Gemini to build that calculator, Gemini knew nothing about PeakTime. Their users, their stack. I don't think probably they told him they are using Vue.js. But the thing is that they have no access, they have no context, and still they can generate. More questions? Cool. Yes.
Which way do you see it going more? Is it going to be, there'll be more full stack designers, or will developers move into the design space using AI?
That is a great question. I think that I was thinking about it also myself today, and I think that it very depends on the type of developer. I think we will see some front-end developers becoming more product managers working with vibe coding or focusing on the design aspect. And I think we will see more front-end becoming more full-stack developers doing also back-end and becoming better at that with AI, because they also have agency now, right? They also have Cursor to help them become a better backend if I only did front end until today. So I think it very much depends on the type of developer and the acumen. I had the opportunity of working with front end engineers that had an amazing product acumen, and I could see how with the right tools they will move towards that direction of designing and thinking about the users and what they want and how do I close that loop from code to production, feedback, and back. And I think there will be some that will move to the other side. Great. Thank you.
Prince, look at you over there. You're just like a little kid with your little candy. I totally, as you said celebratory, I thought you were going to be like, it's my celery. And I'm like, nice try. That is not, it is not. So you said I should stay on this side for the sake of.
Yeah, somewhere between here and
Okay.
the
So this
half
is
of the desk.
this is my no-no zone.
Yeah,
Okay.
exactly. Like you, then you start to get cut off from the video. Hi, welcome everyone. Welcome to the talk on Scrappy UX's tale of effective low-tech, low-prep, and quick turnaround UX research. Our presenter today is Mary Shackshover. Mary, you can take it away.
Thank you. Yeah, it rolls right off the tongue, the name of this presentation. And fun fact, I noticed there's a typo on the board outside. It said it was a Scrappy UXer's tale of effective low-tech, low-petty. So it's not petty at all. This is going to be the least petty presentation you've ever seen. So with that, yeah, I'll kind of quickly talk about what I'm going to talk about, and then I'll tell you a little bit about me, kind of define what my pain points were and sort of why I started doing this low-tech, essentially low effort, but kind of low prep turnaround UX research. Sort of as I got into the process of designing this type of research model, what my solution was to having some of these pain points. And then I'll kind of show a little demo of what that style of research looked like in process. And then we'll take a look and kind of like evaluate it and understand like when does this type of research work well? When is it maybe not so good of a fit? So for me, I won't read all this. I trust that if you're here, you've probably read screens before. But yeah, so I'm a senior interaction designer at Red Hat. So sort of just a little bit about me as a UX person. I double majored in math and graphic design when I was an undergrad. And then during the height of the pandemic, I was seeing what schools were dealing with and teachers trying to turn their, flip their whole classrooms upside down and put them fully online. And I just as a UX person and someone who's always kind of looked into education as being the most important thing for people's futures. That's my perspective. I was like, maybe one day I could do something about this. Me caring about the experience of people, I care about the experience of learning too. So one day maybe I'll see myself in more of that ed tech space. We'll see. So I went on to get my master's in education. And then as far as my career's gone, I've been at Red Hat for almost 9.5 years. So I started as an intern where I did kind of more events, more graphic design stuff. So I would design badges like this for other Red Hat conferences and t-shirts and all this fun stuff. Then when I came on full-time back in 2018, I worked as a visual designer. So a little bit less on the research and user flow side of things, a little bit more on the the UI, how do these things look on OpenShift. Took a brief stint over on developers.redhat.com where I did web design and was kind of temporarily design lead. And then now I'm senior interaction designer on the hybrid cloud console. So kind of almost like a merging of two worlds, working on a SaaS platform. I can kind of see, that web side of things and that I don't have to be a technical expert in just one thing like I was on OpenShift, but I could be a little bit more of a appreciator of all the little cogs in the system. And my UX sweet spot, that's something I always like to ask people, is UX is so umbrella, right? We got the research, the design, your mom, your dad, your cat, all these different things that just make up one field. And my sweet spot is kind of like wayfinding and navigation. So that's kind of related to what I'm going to be talking about. And something else that's kind of worth noting is because like we're going to be here for the next 30-ish minutes, so I'll tell you a little bit about me too. So my work side hustle, as I call it, is that I work with the local K through 12 public schools in Boston to try to get kids into the office or go to their schools and expose them to different things that different opportunities that could exist in a place in the STEM industry. Hobbies, I like crafting, cooking, and trying new restaurants. If it involves food, I will be there and I will be happy about it. And then lastly, you know, it wouldn't be appropriate if I didn't include my pride and joy, Lily, commonly known as Chubbs. Because I could talk all day, I'm just about her and her beauty. I'll just keep going. All right, so kind of getting into the meat of this, I wanted to kind of talk about like, why do I have to get scrappy as a UXer when I'm doing my research? So I kind of looked at it through a few different lenses. So everyone, you know, the world is kind of like, good UX requires research. We have to be data backed. And I'm like, yeah, let's do it. Sounds good. Let's do some research. But in my brain, I'm like, but my product doesn't have a dedicated UX researcher. And I have other things on my plate. But on the outside, I'm like, yeah, let's do it. Let's do the research. So that pain point is I don't have the cycles to do a lot of prep work in order to carry out this research. So that's one scenario of my pain point journey. Another is when the world just broadly tells me, essentially, this service sucks. And I'm like, yeah, sure, let's hear about it. Why does it suck? And but then in my brain, I'm like, okay, because of those other priorities and because someone's giving me this general statement of something sucks, I need to kind of get a little bit of a green light to be able to dig a little bit deeper and potentially put a little bit of time in beyond just research this one specific thing. So that's lots of problems to solve, and I need to fundamentally understand the user's mindset in order to actually solve the problem. So my proposal about kind of how I could solve these pain points for myself when I don't have much time, up here, I didn't say it, but, budget and recruiting are always like, how do you find the people and how do you give them money for making them answer your questions? Those are always issues too, but those are not the ones I'm going to focus on. But those were at the underlying things as well. So I had like no budget, no time, no idea what to research, but new research had to happen. So here we came with ask people about words. They know words, they have feelings about words. I'm not going to show them any pretty pictures, nothing that will distract them from the words. I'm not going to show them any user flows or give them anything particularly scenic to look at. I just want to know what your perception are of words. So I kind of loosely started referring to this as terminology mental model because I wanted to know when you see these words, what does your brain do? Like what fires in your brain? What do you think of? And what connections do you start to make to other words? So I'll kind of show you a little bit more about like what this method looks like, and then we'll look at some examples of what it looked like in practice as well. So basically why I kicked off this study, a service that I was working on that ended up being like a really large chunk of my time was kind of kicked off from a very product-driven, not, some businessy person telling me like the market needs this, but we saw a very like from the ground up issue starting to form. Like we were seeing our usage from customers of this one particular service. It was kind of like an alert manager service. It was becoming really stagnant. People started using it less or not using it at all. And then there was, even internally, the people that work on it, myself included, confusion around what it did and why the terms that we used to describe this alert service didn't feel like it did what we expected it to do. And then we also even had, RFEs or requests for enhancements come through from external customers kind of being like, I want this feature. And I'm like, we have that. Like, why aren't you just using the one that we have? And the response was, I didn't know you had it, or you're not calling it something that I recognize as being what I want. So So kind of what we dug into and what I did sort of a little bit before I did this terminology study was we had evidence of a bad UX, but we didn't know why it was bad. So we had to do a little bit of like discovery research. So I started with a competitive analysis. So I looked at some competitor products to see what their sort of alerting and like alert end user settings, and then also like if you're an admin, how do you configure alerts for people? I looked at what they were doing, spent a really long time kind of analyzing what we do that they don't and what they do that we don't to kind of find like some gaps, and just make sure that I really understood the space. Like maybe there was things that other competitors were doing that we should do that I just hadn't even thought of before. So then this talk to users piece, this is where the terminology study came into play. So basically I wanted to kind of examine and ask some questions about our existing experience and or the existing experience plus some possible other ways that I'm seeing competitors do it, and just get an understanding of what actually fits their user perspective better. So my goals for the research, you know, the competitive analysis helped me understand, all right, what are kind of like the key little bits that have to do with like an alert managing service? And then now it's time to dig in and figure out, now I know what the bits are, what should we call them? What should the details of those bits be? So my goals were to find differences in the structures, the terminology, the patterns, and more across our services and our competitors. I wanted to extrapolate those differences into high-level themes, and then I wanted to focus on the differences in terminology mostly. So I'll get into that in a second. So that was the competitive analysis side. The goals of the talking to users part, or this terminology study, was to understand if the terminology we are currently using meets the mental model or the expectation. Like, if are what we're doing now meeting that, or is there something else that would better meet that? So in a low-tech, low-visuals environment, I want to kind of prompt high-level questions that would sort of invite the users to just have a little spark, but then I'm gonna like let them just like roll with it and tell me what they think. Because some of these things might not be known to me or our product managers or others in the space, so I wanted to learn more. So this second part is specifically that terminology mental model piece. The competitive analysis was just like prep work for that. So the process, again, the preparation was doing the competitive analysis, creating a slide deck to do the actual facilitate the terminology study, create a note-taking sheet. So that's what some of these artifacts looked like. I'm happy to send the templates for any of these if anyone is interested. Actually, I think I posted them in the abstract for this session. So the colorful boxes, that was the competitive analysis I did, and then the other two are essentially the very bare bones, just words slide template, and the other one is the note-taking sheet. So whether it was me taking notes on the user study, or if I had a coworker taking notes while I was conducting it, or if I had to record the session and then take notes later, it just kind of gave me a very like formulaic way to make sure I was capturing the information that I needed. So then the execution step was doing the studies. So for me, that looked like I did 2 one-on-one sessions where I got essentially on a call with a customer or 2 customers, one-to-one, recorded those for about 30 minutes, and then we also did a more focus group study style, where I think we had about 9 people from an existing group that met to discuss their usage of one of our products. And I essentially put this deck in front of them and let them just like rapid fire, like come at me with the words, and then took notes, whether that was me or someone else. And then lastly, there was an analysis phase where I took the responses that I got from the questions that and the prompts that I gave around terminology, and kind of synthesized those into high-level themes rather than just like anecdotal little nuggets of information. I used some AI tools like Gemini to summarize the outcomes from each session. That way I could have sort of like a brief little chunk that could be like, hey, here's the most important things that came out of that one session. And then I summarized all of it into the most actionable design decisions. So what I wanted to do, and let's actually show kind of the study in a few snippets from the study itself. So, excuse me. This is a chunk. The customer in conversation has given me permission to share this, but the name and the company and face has been removed for security. Hopefully audio works? Question mark. Hopefully the video works. Okay, I'm not hearing audio. 1 second. Let me try. So this next, so it's coming from my laptop, but can you guys sort of hear that okay? It's probably going to be really muffled, and you'll just have to accept that it's a free conference, so that's what we get. Okay. Okay. So this next one is, as I've been looking at what a lot of different cloud providers' experiences look like, I've noticed these three terms: event, rule, and policy, that in a lot of cases seem closely coupled. So I'm curious what they are to you. Are any of these synonymous? So this was the deck that I showed, and the user had to tell me their perspective of these terms.
So, event is usually, like I said, that kind of something happens, which it could be a critical thing, could be more of an informational thing, but it's just generically something of note happens, and you need to, figure out what to do with that sort of stuff. So once you get the event and you now need to figure out what to do with it, that's when you start to get into the rule and policy type of stuff. And it is a little bit like kind of context dependent. Like the event's a very like well-defined thing, whereas like rules and policies, it's kind of a little bit more nitty-gritty.
Okay.
Oftentimes what I've seen a rule route create a difficult might be ignored.
So basically, this was the type of research was like much more me just prompting some words and listening. So it was a lot more listening than it was me talking, which usually in good UX research, that is the idea. We're hearing the user, not ourselves. But you'll see in a second here, I think I'm going to ask just like some clarifying, like dig deeper questions.
This statement sounds kind of, does this sound accurate to you based on what you just said?
So I'm repeating back what I heard.
You can create these rules, quote unquote, that will sort of create like a set of like check marks or benchmarks that if an event hits any of those, then that's when some sort of an alert, or as you said, like a page might go out.
Yep.
Okay.
And the page going out, that.
So definitely kind of like a hearing what the user has to say, digging deeper, confirming that I understood what they were getting at, because I was really interested in that nesting piece. Like I'd seen from some of our competitors, I was unsure if event was in rule and policy, are those like completely the same across like Red Hat versus Azure versus AWS? Like I wanted to know, like, is this a very hard and fast, these are their definitions, or is it a little murky? Or are any of these things nested? Is rule like a little baby of the policy? Like I wanted to understand how the user sort of like places these things. Like are they, child-parent relationships? Are they sibling type relationships? I think this is a second one, just with a little bit more stuff.
Okay. So this next one. So this next section here, I'm going to show you a couple of screens. And I kind of want to understand between some of them will be 2 words, some of them will be 3 words, kind of what each of these phrases mean to you. And are they synonyms? Are they opposites? Are they different? So for starters, the phrases notification and alert. What do these 2 mean to you, and do they have any similarities and differences?
So something worth noting here, this was kind of under the covers, sort of like a us versus our competitors. So I didn't tell the customer this because I didn't want to influence them. But in our current experience, we use the term notification. But most of our competitors use the term alert. And I was really curious, are these synonymous to the user? And I learned pretty quickly that there is some juicy info to come out of that. Oh my god, did I... sorry. Let me like here. Okay, it looks like it's taking its sweet time, so I'll just kind of verbally tell you what the user said. There was essentially this perspective that, and this was across the board, this user and the other one-to-one user and the other focus group, that there was this widespread sort of idea that even though they, most of us sound pretty synonymous, that an alert holds a sense of urgency that a notification does not. So a couple people went as far as to say, and this was verbatim quote from not that customer, but a different one, who said, notifications are spam to me. And I was like, okay, cool. So if we're calling that entire service notifications and you're like, no, I don't care, then that would maybe explain why you are not using it. Because you're like, that's a thing I don't care about. And usually we do things that we care about. So that is where that terminology piece came really into play. Is like, it wasn't that we were using a wrong term, it was we were using one that was not matching the expectation of what they expected. Okay, that was like so much nausea, traveling, navigation on my slides, sorry. Okay, so kind of what did we see here and what were the benefits that came from this? So we talked a little bit about how the prep work side of things was kind of my catalyst for doing research like this, because I didn't need designs, so I didn't have to do any like quick and dirty mock-ups or anything pixel perfect. So that in and of itself is like a solid month of work that didn't have to happen. It was just slide deck with words, and that's pretty quick. Minimal time investment. I'm pretty sure, once I had an idea of the concepts and the topics that I wanted to test, I think I gave a total of 2 hours of preparation work to make a slide deck, like aside from the competitive analysis piece, but the actual, just for this, it was just putting together a deck, which is now a template, so this could now be done in like 45 minutes, right? Just, if we take off some of those other logistical pieces of the recruiting and those other things, but if you find like that focus group, that was a user group that already meets every other week, so I was just like, hey, can I kidnap some time on that agenda and just steal your people? And they were like, yeah, do it. And then it really provided me insight into the user perceptions, without me planting any sort of like, here's an idea, do you like it, please say you do type thing. Like, no, it was just, it's words, talk at me. It's a flexible framework, so I used kind of mostly kind of navigational concepts, but you could do this with other things as well. We were able to we did some questions where it was like 3 words comparing them, some where it was 2. We discussed again, like, is there any, like hierarchy or nesting that happens in these? So that gave us a really good idea of like, if we were to turn this into like a navigational structure, what would be like the top most large and in charge nav item there. And it's really easily repeatable because it's just a slide deck. Remove the words, put them with new ones. Amazing, golden, you're good to go. So something that's good, I think, to point out is, while I found a lot of success with this, it is definitely not the right research all the time. It's good for people a lot of the time, but it's not good for some people all the time. So when to use when you're at the very beginning of a project, because this is definitely discovery research, right? Like if you're already like months into a project, it is probably not the ideal time to be like, am I even fundamentally thinking about this right? Like, no, in theory, we want to know that early. So it helps build intuition. And I took basically the things that I learned in this study and then kind of let that drive me where I went with the rest of the design. So if you're looking to uncover pain points, really great for that too. Because even though I was like throwing out some topics, I learned things from the customers of like, oh, here's the aspect that I find most annoying about configuring alerts. So I'm like, oh, that's a little added bonus, cool. And it's definitely qualitative responses. Really, unless you are a full-time researcher and you have the time, bandwidth, and compensation budget to be doing research all day long, you are not going to get that n equals 32 number of doing like 30 to 40-minute interviews with people. That's just unlikely. I definitely don't have that kind of time. So I did 3 total sessions. Again, one of them was a group session, so I did get more people out of it. I think it totaled about 10 people. So that's obviously not a huge sample size, but it's qualitative. And then when not to use, when you have a proposed design already, if you are like, I am in love with this design, it is pixel perfect, you're going to be like a little hurt on the inside and have trouble kind of peeling yourself away from that concept if you find out months in that your idea sucks and I don't like it. And then if you're trying to verify a proposed solution, again, too late for that too. If you are looking for something that is you need a lot of people in order to make your stakeholders happy, not great for that either. So kind of what came after this, I chose to take those high-level themes that came out of the study, and I did a qualitative survey where I did get 30 to 50, I don't remember exactly what the number was, but it was at least 30 survey responses where I essentially had like high-level theme, tell me if you agree, disagree, strongly disagree, or neutral. That way I could make sure that the things that I got from the terminology study weren't just like little outlier snippets. I wanted to make sure that they really were like representative of the larger group of people. And I made some mock-ups, started to list some requirements versus nice to haves based on, how many people felt very strongly about this one topic. And then chatted with my stakeholders and we moved on from there. I definitely want to make sure we have some time for questions or thoughts or whatever, or looking at more pictures of my cat. That's an option as well. I mean, I could just have her up here, just for poops and giggles. Just like, who doesn't want to look at that? But yeah, I will be a person who has thoughts. I can't guarantee answers, but I can guarantee thoughts. If there are any questions.
I do have a
Sure.
question. So after the qualitative, one-on-one list your terminologies, masses, and then you conduct a survey,
Mm-hmm.
and that leads to like a quantitative kind of result.
Yep.
And what happens next? Do you just drop to a conclusion?
Yeah, so just to repeat the question, it was kind of, so we did this qualitative study where we got the high-level themes, and then we did that survey to sort of verify how, are those themes representative of everyone? So the question was, what kind of came next, right?
Yeah.
So for me, that was kind of taking those list of themes and the ones that were like kind of, most people said like strongly agree. That became like, when I listed out like nice to haves and must-haves for like project requirements, those mostly agreed things became like the hard requirements for the project. So I kind of drew up some proposals for those things based on the level of agreement and ran those by like my stakeholders, like my PMs, my eng leads, my architects, to just see like, does this seem like a good way forward? So it was definitely kind of coming up with project requirements was the next step. And then once I kind of got sign off on that, then it was pretty much kind of diving straight into it. I use Figma to do my mock-ups, so I was diving into Figma, starting to look at things, doing a little bit of like information architecture, a little bit of site mapping to show like, hey, here's a proposed navigational structure. What do we think of that? Before I even start designing the things that go on the page, does this mental model, like how do you guys feel about this? Does this break anything we already have?
I see.
Does that answer your question?
Yeah, and that's I think one of
Yep.
And have you? Is there like a benchmark or like a comparison with like normal like other like let's say mock kind of interview versus your terminology techniques? Is there like a comparison?
Sorry, a comparison between.
Like how you sorry, just a lot of in software engineering there's
No,
a
no, you're
lot of
good.
like benchmarking.
Yeah, yeah. I think I didn't so much look at like the benchmarks of things. I more so was really just trying to uncover what are the pain points. And then I think usually it's standard that once we do this type of discovery research, once we have mock-ups and once engineering has started implementing something, it is fairly standard that we'll do some like usability testing down the road. That way we can actually kind of like make a more formal, as you said, like a comparison of let's look at our current experience or like look at data or metrics on the usage of it now. And then once the new version has maybe been like a staging or like a preview environment, see if we see usage start to come up at all. Yeah, yeah, of course. What's up, bud?
What is another case that you can see this type of research being effective for?
Yeah, I know one of my coworkers.
Can you repeat the question?
Oh, yes, sorry. So we did this style of research for looking at like this particular use case was managing alerts, and the question was what are some other topics or other things that we could apply this method to? Does that sound about right?
Yes.
Okay, great. Yeah, so I think as much as I'm frankly sick of hearing about AI, I imagine there could probably be a little bit of looking at that as well. I know I'm working on some projects related to if we have, with a largely technical audience, making sure that we're referencing the right things in our AI stuff. Like, make sure when I say model, I mean model, not agent. Or like, I was given like whatever it is, 9th degree, 10th degree, I don't remember, whatever that term is. Like, I was given hell, essentially, for using model when I should have said agent. And I was like, oh my God, okay, sorry. And so I think hearing from some human beings that aren't people that I work with every day tell me, like, yeah, here's what I think of when I see model. Here's what I think of when I think of agent. I think that is definitely a way that we could go with this, especially given that it's such new territory in the grand scheme of things. People might not have, I think at this point are starting to form biases about what they think about certain terms, but maybe we don't have it super documented yet. So I think that that's one. I also know that exact like rule, event, policy thing. Some of my coworkers on a different team took that research and made use of it because they were working on some sort of redesigns of a policy management service.
We'll take one more question and then.
Sure.
Yeah, I just wanted to, it's more of a comment than a question. I wanted to let you know, Mary, that you inspired us when we were doing some research on the perceived differences between a model registry, a model catalog, and a model, is it model garden? All of those terms are used as repositories for models. And one of the cool things about the technique is that it's so open-ended. You don't give the person a lot. You just give them those terms and you kind of let them go. Yeah. And you learn so much more beyond just what they think the difference is between those three things.
Yeah.
So I really like that part of the technique.
Thank you. And now I'm enlightened that a freaking model garden is a term. Just grow your AI flowers with us. I wouldn't say most radical. I would say literally because a coworker on our team has taken this very literally, guerrilla style UX, where you go at people at conferences and just facilitate feedback. Someone dressed up as a gorilla and did it. And the same person also invested in a robot suit and planned to bring that to Red Hat Summit, but was promptly shut down by brand because it didn't fit the narrative. But yeah, I would say I don't know. I kind of feel like UX research, like, it's so hard to get approved for like large budget to if you're to like get a lot of external customers. So I think, you know, we're all pretty. The reason why I called this Scrappy was like, there's a reason why we have a booth up there is because we're just like, talk at us, like, just engage. And so I think all of it can feel a little radical sometimes because we need to just do like a song and dance. I have danced in a hallway to be like, come do a workshop, like, and yeah, you got to be a little bit of a fool sometimes, and it's a good time. Lily. Thank you.
slightly bigger group. If I just stand at the front, it's going to look like. Are we both in the frame? All right. All right. Thanks everyone for being here. So the next talk that we have is the 10 Steps of Container Security by Boaz Michaeli, product management on the Red Hat Advanced Cluster Security team.
All right. Thanks everyone for joining online and after lunch in the room. We are going to talk about container security, but first, at a show of hands, how many people have administered a production cluster ever? Oh, quite a few. Let's see your scars. How many people in the room write code that gets run as containers in production? That's a good share. So this talk is for all of you. Well, cluster admin, you have just provisioned a most secure cluster in the world. You're probably using OpenShift, which is secure by default. And you are so advanced that you probably went ahead and provisioned some pod security standards as well. So you've looked at your workloads and you actually kind of understand what's going on. But the question becomes, how do you help your team maintain container security? Because you know what they're going to do. They're going to do everything they can to break it, right? So what we're going to review is, and the answer actually is, I'm in delay of one slide, aren't I? This was that slide, process. And the answer is process. Now, I'm going to go through a lot of detail, and I apologize, some of these slides are eye charts. Don't worry about them. There's going to be a takeaway out of each slide. It's really focused on process, what you two can do together, but it is very technical, honestly. So there's going to be a lot of detail here for you to just use afterwards. So try not to get distracted by the level of detail there. So we're going to talk about what do you do during build or code/build phase, what do you do when you deploy, and what do you do in runtime. So starting off, I'll try to talk about what the risk is and then how do you mitigate it. The first thing that I need to make this a little larger. There we go. So the first thing that most users, our customers do is they worry about vulnerabilities. It's still, even though there's a lot of debate in the industry, it's still considered the first thing you want to do is get rid of known vulnerabilities. So the first thing that you should do in your environment is integrate an image scanner. Some do it in code, but if you're using something like StackRox or Red Hat ACS, that's built into the system. Get into the habit of scanning base images and get into the habit of maintaining those approved images that you've scanned for base images. But also, and this is process, you need to establish a process for regular scanning of your approved registries or the images that come into those registries. And you need to think about what are you going to do with that. We'll talk more about that, but the essence is we're already talking, right? You need to report back to the developers because how do you fix a vulnerability in your process, in your image? Anyone? How do you fix a vulnerability in your image? You replace it. That's the only thing you can do. You have to replace it. You have to rebuild the image. And so there's already process there. Next, you've already integrated the scanner, but now we're into what do you do during the build itself and why. So there are a couple of different areas that you want to consider like why an image may be unsafe for you. And there are two like supply chain examples and actually image examples. Now, from a supply chain perspective, you may only approve in your organization which registries you allow your users to use. That's what you should be doing. What if the image is not signed? So go back. You need to think about this. You need to think about how you're going to sign your images during the build, but you also want to verify them. And there are a lot of bad things that can go into images. So for example, and we'll talk more about this, what's called living off the land. Has anyone heard about living off the land? Living off the land means that attackers, whereas in the, let's say, VM days, you'd have viruses and antiviruses and long living, and they'd penetrate and rely on you to make a mistake. Living off the land means that attackers just use whatever they have. So if they can use an API, if they can use wget, if they can use CRL, they're going to use it. Why would you have a package manager in a pod? You shouldn't. So what you should do at that level, this is your, assess image policies during your build, which means first you have to establish those security policies. So security folks, it's up to you to establish those security policies. Now you want to integrate them into the pipeline. So something like StackRox command line, you integrate it into the pipeline and you can selectively fail the build. So the key takeaway from this stage is, after you've established your security policies, is don't hesitate to fail the build when you need to, because that's the only way to force correction back into the process. Next, we're still in the build process, but now let's talk about workloads. And so in my intro, if you read the intro of the talk, I promised to talk about the two different types of policies in StackRox, but given time, I'm going to limit it. But there are image policies and there are workload policies. But the fun part is you get to check both of them in the build stage. So what are workload policies and why would you use them in the build stage? Is because now your threat is that your workloads don't meet your security policies. And there's so much that you can do wrong with a container. But it's also that the image associated with that workload doesn't meet the security policies that we just talked about. So you have to think about both. You have independent scanning of images, but when a workload comes and says, hey, I'm going to use this image, you want to make sure that image has passed your approval. There's a ton of examples of bad things that you could do in workloads. Actually, Kubernetes is insecure by default. OpenShift is secure by default, but there's still a lot left for users to go wrong. So you really need at this stage to establish your workload security policies. Go look at best practices. Compare with a pod security admission that has been introduced in, a couple years ago now? And that's a good start, but that only kicks in upon admission. It says, I have 3 classes of securities. I'm going to let you do A, B, or C. Here, you have more flexibility and more control, and but you are forcing developers to do the right thing. So you're actually going to tell developers, no, you need to change your YAML so that you drop all capabilities. The other thing is, and I hope that you're doing this, but in your pipeline, we talked about the build pipeline. You're building an image, you're sending it to a registry that it's going to get used later. You should be doing exactly the same thing with your YAMLs. They should be approved and go into a repo later to go into production. So implement that check en route to where you're going to store it. Set up a process to inform your developers about these policy violations. How are they going to fix it? How are you going to let them know? If it's StackRox, you get a big explanation in text about what you're doing wrong and how to fix it. It's not always enough. And again, selectively fail the task. Now, selectively is important because you don't want to slow your developers too much, but at some point, you're going to need to put your foot down. The next thing you want to do at this time is think about network isolation. Now, this is hard. It is so hard that very few people do it. How many people are familiar with Kubernetes network policies? A handful. And how many have implemented Kubernetes network policies? That's nice. Still those handful, but just a little bit. It is very hard. But if you want to learn more, come talk to me at KubeCon. I'm giving a presentation about how we can help you generate network policies just based on your YAML resources. A fascinating topic. If anyone wants to talk to me later, please do. Whichever way you do it, don't think this problem goes away. You need to isolate your networks. So we're done with the build stage and we're into deploy. So what are we going to do now? Is we're going to run the same checks again. Why? Because the risk is still your workloads don't meet your security policy criteria. Maybe it's one of those workloads that you let pass in the pipe. Maybe something changed, a new vulnerability has been discovered. Maybe you've updated your policies since. This is really your last chance to check a workload before you let it in to your production. Use an admission controller, such as, again, with StackRox or the ACS, to reject violating workloads. And in StackRox, we also actually have a fallback. We would either use the admission controller that's built into ACS, or we would try to scale the deployment down to 0. This also brings back the point to what do you as a security admin do with those policies? There's a lot of tuning. Think about how you're going to apply those policies to namespaces, to applications. Who are you going to exempt? What are you going to include? What are you going to exclude? If you're new into this and you're starting off into production, take it slow. Choose a cluster to begin with, a namespace to begin with. So there's a lot of thought that you need to put into this process. And the takeaway is establish a violation management process, again, back with your devs. So violations are going to show you all kinds of security violations from the policies that we talked about. They're going to show you vulnerabilities, and they're going to show you security violations. So some of this is going to go back to, I already have vulnerability management. Okay, go fix it. But if you have other violations, like how long do you allow developers to have these violations around? Is it 30 days, 60 days? Why? What severity level? And have that conversation between security and your dev team. Setting up that process, by the way, also involves thinking about a back-end system that's powerful enough, and usually enterprises have back-end systems that are powerful enough. So violation management isn't an afterthought. There's a lot of back-end and process into that. Now let's talk about runtime. The security in runtime is, first of all, you've got something running. You already checked it. You checked the image in the build. You checked it in the deploy. Everything's great. But now it's running, and a new CVE was found. What do you do? So cluster admins, how many of you kill that application right there when the violation is found? Severe, critical violation. Do you kill it? Luckily, nobody said yes. Why? Because that is a way that we call how to automate an outage. If a new CVE is found, you take the application down, it's trying to come back with the exact same violation. So that is a problem that you cannot automate. This is one place where you have to establish a process on how to monitor those new problems and decide what to do with them. And obviously, you're going to have to rebuild. But by the time it takes people to rebuild, you're exposed. It's something to consider. We don't have a magic solution for that. The next one, this is fun. There's a lot of fun in looking at what containers are allowed to do. And we have a saying that containers should be boring. They shouldn't be doing anything out of the ordinary. They shouldn't be doing fun stuff like, if I see a package manager, again, in a container, I should have prevented that long before. I should have not allowed it to do SSH because there should be no SSH in the container. But as you know, security is just layers upon layers, check and check and check and check it again. So if you see any one of those suspicious activities, and I know the text is too small for you to see, but there's so many interesting things that you can check with containers. The point is that you have now to think about runtime. So thinking about runtime is, what are the type of behavior that I do not want to see processes in my containers doing? And of course, you want to alert. I didn't mention this before, but any type of violation, you need to choose if you're going to only alert or also enforce. Same case here. Except in this case, I would say you can confidently terminate offending pods. Why? Because they're going to be respawned. So this is different than what I just said before. If you take down an application, it won't be allowed back in because it's violating an entry policy upon deployment. In this case, the assumption is that something changed in the container. Somebody penetrated it. It's not doing something that it's supposed to. Kill it, it will be respawned as clean. I think I'm going well in terms of time, faster than I expected, so I can, if anyone has questions during, feel free to interrupt. Taking another spin at this, there are two ways to look at process and network behavior. Like, one is you want to inspect, and there are certain rules, the things that you want to prevent. Like I said, you don't want to have SSH. You don't want to have package manager. Also, from networking perspective, most organizations say you're not allowed to have SMTP. Why would your container need SMTP? Well, it's what it does. It's an email application. Okay, that's going to be an exception. Nobody else is allowed to use SMTP because that's a way out of your container. So the question becomes, how do you establish what is a good behavior? And that's a hard problem. StackRox gives a couple of tools for people to establish network behavior and process behavior. On network behavior, there's actually a chart there that's a little bit hard to see, but StackRox examines what's going on with the network, and after some time, it just says, well, this is normal. And usually it is, and you can refine it. Process it a little bit harder, but that doesn't mean that the problem isn't there or that it's not a good idea to have. So going back to that, pods should be boring, it's the same statement, except one is proactively identify what you don't want, and the second is just behavior-based. If you understand what's a good behavior, anything that deviates from that should be stopped. And there's one particular element that helps attackers in their what is called the kill chain. So what do attackers do? They find some footprint, some leftover credential, some easy, like non-suspecting pod that nobody cares about, and they're able to enter it. But that's their entry point. And from that, they try to escalate. So after they have this initial access, they're going to try to enter another pod. And the way they're going to use it is, one, they're going to use the tools that you give them to. So which means any pod that is out there, it's a research pod, it's a lab pod, that can serve attackers as an entry. So do not underestimate those low-life containers because they can be used to penetrate others. But this particular one is pod exec and forwarding. So these two API calls is what allows usually us as debuggers to go in and into our pod, right? You want to do a pod exec, so from your machine, fine. But nobody else should be doing it, and that absolutely should not happen in production. So these are two just dangerous API calls that StackRox can block, and the recommendation, the key takeaway again here is absolutely block that in production. Do not allow these two. if you succeed in doing that, I don't know if you how far people can see it, but right there you're gonna cut the rope on the kill chain. And we're on the last step. So the last step here that I talk about is looking into some of the sensitive things that people may do that we haven't trapped. And specifically, this is any access to sensitive Kubernetes resource. Meaning, if somebody is modifying a cluster role binding in production, in runtime, which is not going through your GitOps process, where it should have gone through, that's not a good sign. So they may be attackers trying to give themselves permissions. They may be trying to cover up their tracks. There's a whole bunch of sensitive resources like config maps, network policies, security constant constraints that nobody should be messing around with. They shouldn't be looking at them, and they definitely should be writing them. So magic bullet there isn't, because what you can do here, again, with StackRox and ACS, is you can monitor. And based on your monitoring, you then have to decide what to do. So we're a little bit early in time for questions, and I'm happy to go back into anything that you want more detail on. Go for it.
Yes.
Yeah, you won't hear yourself. It's just for the
Okay.
recording.
Sorry. Yeah, so here, do we assume the attacker is inside the pod, or is he trying to exec from outside the pod?
Question was, do we assume if the attacker is already in the pod or trying to exec? So the case here is that the attacker has penetrated some pod in your cluster, not your pod maybe. You're good. You're a developer following good practice, but they penetrated a lab pod that somebody left behind. That's how they're going to start. This kind of brings in the, how many people have heard of zero trust? Wow, good. So zero trust architecture, but the concept is exactly like you said, assume breach, assume somebody's in your cluster already, and they're going to try to move over to your pod.
How can they do that?
So how can they do that is, again, so the question is, first, how can they penetrate a pod to begin with?
Let's say they have access to one of the pods. How can they access another pod from inside your current pod?
So that's exactly how you would do that. Is you would use pod exec, and you would then gain permission from your pod to enter another pod. Just like if you do exec from your terminal and you're now running a shell inside your pod, somebody can do that either with kubectl. They don't have to have kubectl. They can write a script that calls the API directly. Say again? With curl, but you're doing a good job. There's no curl on that. Let's say on that lab image, there's no curl either. Even if it's a relatively thin, if they have access, they can write a script, and if they can do pod exec, that's it. They're in your container. Is there a product that can run and?
There are products like Prisma Clouds and Tenables and other things. Do we have any other products which can monitor these kind of traffic which is going out of the pod, or some attackers coming into the system and seeing what kind of bits and bytes are moving out of the pods? Can we do?
So the question is there any way, any product to monitor the traffic coming out of the pod? I think the question is
overall pod security itself, not just network traffic, but from the pod security itself. Hey, this pod should not have a curl, right? Can I run policies to make sure that it's not doing that across the cluster itself, not on the pod, but on the cluster itself?
So the question is, can we actually apply those clusters, those policies on the whole cluster instead of
Right.
like pod by pod? The way to do it is workload by workload. So this is about, I mean, what's a cluster? It's just a few nodes. And if you're asking, is there some oversight to look at everything that's happening and prevent that? So there is the pod security admission, which runs pod security standards. This helps in a sense of looking at what pods are allowed or not allowed to do, but just from not just, but from some restricted perspective, because it's looking at things that a deployment should do. It shouldn't run as privileged. If it's running as privileged, it would get bounced. But from the other things that I talked about, like how would you know if there's curl in the image, is exactly follow the steps that I said. Start with the build. Make sure your developers don't put curl in the image. Check it again during deployment. And check it yet again in runtime. If somehow it escaped and somebody's actually running curl, StackRox will trap that. So if you're wondering, so ACS or StackRox. StackRox is our upstream. So StackRox monitors everything. You don't have to say, hey, I want to start monitoring ABC. All your pods are being monitored. If we see a curl coming out of any process in any pod, the policy will kick in. Go for it.
I was going to say, the basics of least privilege and CTA, you're basically saying, okay, all right. Yeah, I mean, the basics, you control what your users have access to, and you control what commands they can run, and you also harden, even before we had the cloud, we had the idea of hardening servers, where you basically said, you can't run these commands. These services aren't going to be installed on a server, and you basically carry that over to virtual machines and to containers. So basically, you say you break it down, you harden it, you don't allow users to have certain permissions, and you don't allow the containers to have those different applications or commands available to them. So yeah, you just basically create a kill box, and you harden it down to the point where it's like, okay, what's the base functionality do we need? And of course, whether it's policies or firewalls or whatever different layers of the onion for security that you create, so that you can have multiple ways to cut it off.
Yeah, absolutely. And so that actually, brings another perspective. So the person, your name? So Mike was saying it's layers of security, but fundamentally you want to harden down your applications just like you do anything else. So here's the question. So developers out here, how many are using really lean base operating systems like Alpine or something else? How many people did not fully grasp the meaning of my question? Don't be shy. So you all understand why you should be doing it, and yet only a handful are doing it. Why? It's hard. Why is it hard?
Why is it hard to use a lean image? Well, I don't know. It wasn't so hard for me. I was trying to design. In fact, in some cases, I'm using a from scratch image. I'm building, a completely static binary or whatever, and copying, only exactly what I need. So the only thing that runs in my container is literally
Kudos.
which is hard, right? But it means that you need to do different tool chains, different whatever. People may not be familiar. I'm not sure why people think it's hard, but I think that. And it may just be that they've heard it, but they're just familiar with, use Ubuntu or whatever, basically, just something simple that they know already. I don't know why people don't.
Okay, so some people find it hard, even though it's questionable why it is hard. Behind you?
Well, maybe a related thing. I'm running Silverblue. All of my boxes run Fedora CoreOS, where the hardware will support it. So yes, I do run that stuff. The reason I'm comfortable doing that is because I was working on the OpenShift team and with people who are working on it at Red Hat while those things were being developed. That makes me comfortable. So I write a bunch of blogs about that. But that leads to many of these, you're describing how to create the policy, but the biggest problem with this really is helping the users understand why, the developers, why a minimal container is desirable and is worth the effort. I mean, I'm going to go up to the Docker, the container thing in a little bit. I have a container image that runs DHCPD. It's 16 megabytes. It has one binary and the 12 libraries necessary. I have a script that regenerates it from RPMs. But it took me a while to do that. And again, I'm a person who's already comfortable with this.
Right.
I don't know how to get people. How do you convince developers? How do you persuade them? Because enforcing it, if you try to force them, they're going to do the easy thing.
That's right.
How do you get people so that the right thing is the easy thing? Because that's the only way that they're going to do it.
That is the key question. So thank you. So how do you get the team, as a team, security and developers, to agree and understand that it is important, that it's important to take that effort, and that it's important to minimize the attack surface on your containers with everything that we've talked about? Right. Yeah. Yeah. So again, just to repeat, a great feeling is if the VP comes in and says, there's a dangerous vulnerability out there. What are you doing about it? It says, we already took it out. It's not running on our machine.
I think one of the big things is that the thought process for living on off the land attacks is so alien to the thought process for developing and running applications that it's hard to get into that, headspace. And the reason that things like curl and wget are not desirous to not have in containers, people don't think of, the kinds of network attacks that you can do with a bare Python interpreter or a bare Perl interpreter. But those things do have the capabilities to reach out through sockets. And if you can write to a socket, you can make an HTTP API call. And if you can make an HTTP API call, then you can call against the Kubernetes API or any other API that's there. And, as you kind of walk through what you can do, people don't think, oh yeah, I'm going to use Perl to attack the Kubernetes API, but it's absolutely possible, and people do.
Right. So thank you for that reminder. Now, there's a whole topic, many blogs, many videos that show you how attackers use those tools to do that. Now, if you're going to educate your team, that might be a good path to take. I'm going to take a last question back over the back.
One thing I think that would help developers actually use minimum images and all these things is actually having a company or a source of good supply chain that actually should be handling that, and not be the developer himself building a from scratch image and then having to maintain that along with the application that they're trying to deploy as well. So I think it's automating those build systems. Oh.
Yeah, no, it's fine.
You're good. Automating that build system, then the maintenance, and having someone you can trust actually be doing that build for you, and you being able to be okay, if I want to develop a Python application, I have a golden Python minimum image that I know will always work, and if something doesn't, there's a vulnerability or something, that company will go and handle it, and kind of help you remove that load from you, and you can focus on your actual business core, development stuff.
So the question is a desire for somebody else to solve this problem by way of making sure that there's a secure supply chain that we're going to lean on. There are efforts like that, but any large enterprise that I talk to have that process inside of their organization. So supply chain is critical. And if you're working for some of these companies, as a developer, you're going to be restricted. You're not going to be able to use any Python module that you like. You're going to have to use the one from the registry that's been approved, that's been scanned, that has been signed, that goes through all those checks. That's why this is a process. And if I'll just wrap up and kind of go through the 10 steps that we just talked about. Maybe I'll take a step here. I don't know if the camera can catch me. So starting from the build from the build phase, you want to make sure you're integrating the image scanner into your pipeline and that you're doing both assessing images actively as well as assessing their policies. So process, think about you need a policy to secure images. You need a policy to secure workloads, and you want to assess them. Don't forget to develop network Kubernetes network policies. It's a big problem, big topic. Don't give up. In deploy, use the same system to reject some of those dangerous violators. And think about your runtime security. What do you do when new CVEs are discovered? How do you prevent unsafe process container, whether it's behavior, whether it's specific process that you've identified? How do you cut the attack chain? And how do you monitor access to sensitive resources? Our time is over. Thank you very much.
Access it, and
Oh, all right. Here. Yeah, it is. Do I talk into this mic right here?
Yeah.
Okay.
Oh, okay, cool. All right. All right, we're going to start the next session if I can get everyone's attention. All right. Introducing our next speaker is Jake Carenti, software engineer at Red Hat, working on confidential computing and virtualization technologies. And his talk is Demystifying Confidential Computing, a technical update for enthusiasts and professionals.
I know where I want to be now, though.
Hi, everyone. Thanks for coming out. Skip the first couple of slides because kind of already done for me. But yeah, my name's Jake. I'm a software engineer at Red Hat. I work in the virtualization team. I mostly work on a project called libkrun and the associated projects along with it. But I think the first thing we should do today is talk about what exactly is confidential computing. First off, data encryption technologies aren't a new thing in our industry. We have storage encryption that protects your data at rest. We have network encryption that protects your data in transit. But what about your data in use? And when I talk about data in use, I'm talking about the data that's in your CPU registers, the CPU cache, and actually in your RAM. Well, confidential computing is the protection of data in use by performing computation in a hardware-based, attested, trusted execution environment. And trusted execution environments, or TEEs for short, there's different ways you can implement them. But the industry has converged towards implementing TEEs through virtual machines. And this is just proved through the fact that it's easier and honestly just more convenient to port your applications towards them. So really what our goal here is to provide data confidentiality and prove through something called cryptographic proof or attestation that what's running in your VM is exactly what you're expecting. And like I said before, there's different ways you can implement a TEE. And of course, each chip manufacturer has a different architecture for how they create their VMs. And because of that, I'm going to focus on two different chips, Intel TX and AMD SEV S&P. ARM and IBM and RISC-V all have different architectures, but for the talk today, that's going to be out of scope. So first off, I want to kind of outline what does a standard VM look like. For the sake of the talk, we'll call this an untrusted VM. And on the host, you have your host kernel, you have your physical hardware, think your CPU, your devices, your storage, and then there's also a hypervisor. And then on the guest, you have virtual firmware, you have a different guest kernel, possibly. You have your emulated devices, and then you have something called shared memory, which is memory that's accessible between the host and the guest. The issue with these untrusted VMs is you're susceptible to attacks from basically every direction. You have to worry about other cloud tenants. You have to worry about people with physical access to the system, possibly a malicious sysadmin, rogue devices, and let's be real, even accidents. But the goal of confidential computing is to mitigate these risks through hardware assurances. So in a confidential system, we actually start off with the same kind of basis. We actually don't trust the guest right off the bat. But what we do trust is something called the hardware root of trust. This is basically just a certified piece of hardware that has the ability to actually measure the contents of the VM and then sign it with a key that's provided at manufacturing time. And then we also depend on something called an attestation server. And this also has to be trusted from the start. And basically what we're doing is this attestation server is going to validate the measurements and prove two things really. One, that the hypervisor didn't lie and that we're actually confidential. And two, that we're running only what we're expecting in the VM. So there's no extra memory, there's no random binary that showed up. So we can really break this whole process down into a couple steps. First off, the guest is going to communicate with the hypervisor on the host and ask for an attestation report. The hardware root of trust will provide the attestation report. This is going to include, like I said, measurements and a key. And then the guest will provide that report to something called the attestation server. The attestation server will then compare it to some reference values it has. And as long as the measurements match up and we can actually prove that we're running confidentially, then the attestation server will provide the guest with keys that it can use to then decrypt the root volume and then possibly other devices as well. So that's kind of the quick rundown of what the confidential computing architecture looks like. So I think now it's a good idea to talk about some of the projects that Red Hat has been contributing to in this space. And I do just want to make a quick disclaimer that I'm not going to be giving a deep dive into all these different technologies. Each one of these could be their own presentation here today. But if you do want a little more information than what I'm going to give today, my manager gave a talk last year. He goes into more depth there. And of course, you can ask questions or find me in the hallway after too. Okay, so the Linux kernel is really the cornerstone for all of the work that I'm going to be talking about. And without Linux kernel changes, none of this is really possible. So guest support came into the kernel first in version 5.19. That includes SNP and TDX. SNP was first to the punch on host support in the kernel, which was in 6.11. And then most recently in 6.16, TDX host support was merged. If you're looking for a more enterprise solution, all of these changes are also in CentOS Stream 9 and 10. I just want to really reiterate the fact that this was a lot of work going into this. This was years and years and hundreds of patches to get in. So just massive kudos to those people involved. But now that those changes are in the kernel, other tools can start taking advantage of the functionality. So things like QEMU, which is a really popular open source VMM, supports SNP in 9.1 and TDX in 10.1. And then libvirt follows suit with SNP support in 10.5 and TDX support in 11.6. But what if the workload you want to run in the guest doesn't support these cutting edge Linux kernel versions? Well, in that case, you're going to want to use a Paravisor. And the project that we see filling into this space is called Coconut SVSM, or Secure VM Service Module. And SVSM is really a guest firmware component that provides you with secure services and device emulations to the guest operating system in a confidential VM. At the moment, there's no official release for SVSM, but the team has been doing monthly development releases that are actually leading up to this official release. One of the really big efforts that's going on right now in this space is to come up with a complete attestation solution with a stateful VTPM. And then we're also working towards adding host kernel support for SVSM. This is going to be planned for early 26, hopefully. I do also want to point out one important thing about SVSM, and it's that currently it only supports SEV SNP guests. There is some ongoing work and discussion surrounding TDX support, but that's still very open-ended at this time. another thing that we need to consider is before the VM even boots, we need to be concerned about security through the boot chain. And we can do this by extending Secure Boot to actually cover the init RAMFS and the kernel command line by using something called UKIs, or Unified Kernel Images. And basically, this is helping us prevent things like someone swapping a binary on us that could be malicious. And this is helping us prove that no objects in our boot chain were altered. And this can prevent attacks on the guests before the OS is even booted. There are some inherent limitations with UKIs, in that things like the kernel command line or the init RAMFS are immutable. So one thing that we're working on right now is essentially to find a way to whitelist the kernel command line or the init RAMFS to provide some more flexibility in that sense. So I've talked about attestation a little bit up to this point, but when we talk about attestation, there's really two projects that we're focusing on. The first one is called Keylime, and Keylime is a CNCF hosted project, and it provides you with highly scalable remote boot attestation. Then it also provides you with runtime integrity measurements, and this opens the door up to something called runtime attestation. And then another project that we're contributing to is called Trusty, and Trusty is a confidential containers project, and it can provide you with components to deploy on a trusted system to do remote attestation as well. So in this area, another big effort going on is in combination with something like SVSM, we want to use both of these tools to do attestation. First off, we want to do pre-boot attestation with Trusty to actually unlock the root disk. And then after the initial boot and the initial attestation to unlock the root disk, we want to use Keylime to do subsequent runtime attestations to continuously validate the integrity and the confidentiality of the system. So I've been talking a lot up to this point about VMs, but we can actually extend the VMs to enable cloud-native confidential computing workloads at the pod level. And we can actually do this with something called confidential containers. And confidential containers is a CNCF sandbox project, and it can help you seamlessly deliver confidential workloads via multiple trusted execution environment platforms and development models. I think AI is really popular right now, so maybe it would help to contextualize this a little bit. So let's say you have a workload in two pods. You have maybe an inferencing pod and a training pod. One thing you have to worry about in a standard VM scenario or standard scenario is maybe a malicious sysadmin wants to snoop on maybe your model parameters or your model data. Well, what we can do is we can encapsulate those pods in these confidential VMs and prevent external entities from getting unauthorized access to anything. So what we can do with confidential containers is actually sign the container images to prevent them getting tampered at launch. But we also require the workloads to have secrets to perform their operations. So before we can actually do any training, we need to decrypt the training data. Or before we do any inference, we need to decrypt the trained model. And these are separate keys also. So the only way we can get these keys is by a successful attestation. And confidential containers is a really big project within the Red Hat space right now. We're at the point where we're starting to hopefully distribute it out to customers soon. Confidential clusters is very similar to confidential containers, except that confidential clusters focuses on integrating confidential computing tech into Kubernetes clusters. And this uses something called image-based Linux OSs and bootable container images. And the premise here is that before a new node can be added to a cluster, it also has to be successfully attested. So OpenShift confidential nodes on CVMs is offered with SEV, SNP, and TDX on Google Cloud Platform in OpenShift version 4.19. The CVM offering with SNP on Azure in OpenShift 4.19 is also available, and then TDX will be in version 4.20. And similar to a lot of the other projects I've talked about today, the investigation into remote attestation is constantly under development. This is a really hot space where there's a lot of discussion and POCs going on. So with all of these different projects that we have, there's of course an attempt to limit the amount of code rewriting and reuse of really just writing the same code in multiple places. So with that, we created a organization on GitHub called Verdi, and this is where we house all of our shared libraries and tools. For example, we have Rust libraries for SEV, SNP, TDX, and also some other architectures I said I wasn't going to talk about, but ARM-CCA and AWS Nitro. And what this does is it allows us to create a really easy interface for people to actually bring up these VMs programmatically, rather than having to go through all the different KVM APIs. We also have CLI tools to interact with SNP hosts and guests. And of course, these tools are continuously under development. The TDX library was our latest accomplishment. Like I said before, we have our CCA and Nitro libraries that are in development right now. And then we're also planning on adding other CLIs for different architectures as well. Primarily, TDX is of concern right now. So one of the main consumers of these libraries and tools I just talked about is a project called libkrun, which is what I mostly work on. And libkrun is a dynamic library that provides you with virtualization-based process isolation. And libkrun is a Rust-based VMM, which is the host portion of a hypervisor, but it actually provides the user with a C API. And libkrun VMs are really just micro VMs. So what this means is we're really shooting for low footprint, low memory footprint. We have a minimal kernel. We have minimal devices that are emulated. And we've implemented SNP, TDX, Nitro, and CCA into libkrun. So it's a really well-rounded confidential computing solution. But what makes it interesting is it's so heavily integrated into the container ecosystem. We've extended the crun runtime with something called the krun runtime. And this interfaces directly with the libkrun API. So if you're on a TDX host, for example, you can use Podman like you normally would, and the container that you'd bring up would be encapsulated within a TDX VM, which makes it really, really easy. So I wanted to leave it nice and open for questions since I covered a lot of topics.
So
No, you're fine. You won't hear yourself.
Oh, okay. All right. Those who are online can hear me then. In a confidential VM, is both the code and the data encrypted at rest? So when it's in memory?
In use.
In use.
Confidential focuses on data in use. Something like Lux would. Okay. The question was, in a CVM, is the data in code at rest encrypted? Confidential VMs focus on data in use. The technology that would be worried about data at rest would be something like Lux encryption on a disk.
Okay. But you do need to decrypt it before you do operations inside a CPU, right?
Yes.
Okay, so it happens at the CPU.
Yes, you do need to decrypt the root disk before you can actually do anything in the guest. So a really basic example is in a confidential VM, let's say focused towards a container workload, you would have an attestation agent built into the init RD. So right when the init process starts, it will do the attestation, and then once it unlocks the root disk, then it continues to boot as normal.
Okay. So let's say if you have a web server running in a VM, that application data is encrypted in RAM.
Yeah. So if you have a web server running inside the guest,
yeah,
your question is what's running on the web server encrypted?
Yeah.
Whatever is in memory at the time would be encrypted. Yes.
Okay, and then it gets decrypted before it's in the CPU. Because I don't know if you can do operations on encrypted data. Like if you have numbers, you need the numbers.
Well, think of it like the question was surrounding how the encryption works within the guest vCPU. Correct?
Yeah.
Think of it like the memory is encrypted from people outside of the VM. The VM itself can see what's going on inside the guest.
Okay.
So think of it like if I run a confidential container with Podman. In theory, a normal Podman container's memory can get snooped on by some other process. By wrapping it around a confidential VM, that memory that you can technically dump in a non-confidential state would just be mumbo jumbo. It would be unreadable.
Okay.
Does that make answer? your
Yeah,
question?
that makes more sense. Okay. All right. Thank you.
Like on all the different topics. I don't have one slide with everything. No, sorry. Sorry, the previous question was, do I have a slide that lists all of the different topics I talked about? And no, I do not.
You said it uses.
You're fine.
Okay. Yeah, you said it uses bootable Linux container images. Is that boot C?
My understanding is it uses the same technology under the hood.
Same as what?
As bootc, but I'm not
Okay.
100% sure. I don't work on that area of the projects, but if you want to talk to me outside, I can figure out for you.
Thanks.
What are the areas where you're looking for more assistance, and what are some of the problems that require more external assistance from the Red Hat team?
It's a great question. It was around, where can other people step in and help, and where do we see the most help needed from the Red Hat point of view? I think that from the SVSM point of view, I'll go back to that slide. Right now, it only supports S&P, and I think from our point of view, we see this as a really good option as a generic solution. But that also means we need people like Intel TDX to have support there, ARMCC to have support there. Whether that happens kind of depends on other people as well. I think the topic of attestation is always an area that has ongoing development going on. Everything is still very much up in the air. And we've been working on this for years. So I would say definitely those two areas are, from my understanding, that kind of need the most TLC still. Any other questions?
How are you guys going about like making it easier to do the UKI stuff that you were talking about with being able to actually modify the command line in MRMFS? Is there like a project that's like doing that has like a better way to modify UKIs and still not break the signatures and everything?
Yeah, so the question is around, how are we making it easier for people to make UKIs less difficult to work with? I know we do have people working on it on the confidential clusters side of things, because that does make heavy use of UKIs. But in terms of specifics, unfortunately, I don't know. But I can find out for you.
Okay. Yeah, because I know that bootc, bootable containers themselves are looking into that, like making sealed images, and so if that gets better, that's good for them as well. So that's it.
Any research being done around ARM?
The question was, is there any research being done around ARM? CCA to be specific. We do have people working on not only reviewing the CCA patches upstream. I think those are getting really close to being done. There is ongoing CCA work in libkron specifically. We have a library that works so far with the patches that are upstream. And we do have a POC that works with libkron as well, so we are able to create confidential VMs with CCA. But where things are still kind of fluid upstream. Nothing's really solidified yet.
Still have time for questions.
Try to leave plenty of time for questions. A lot of topics. If there's any other questions, you can find me. You can find me around. Thanks, everyone.
You're on. Hi everyone. Thanks for joining us for the talk on FIPS compliance. I have the pleasure of introducing two of my own staff members here at Red Hat, Yashwardhan Nanavati and Nate Marcella. Take it away, guys.
All right, thanks, Manish. So we're talking today about the Federal Information Processing Standards. Yash and myself, we're on the same team. We've been at Red Hat for quite a while, a combined 17 years of experience building and maintaining CI/CD pipelines, some microservices, some tools. So we also, maybe you can see the sticker on my laptop here. It says Conflux. So that's a new build and release pipelines at Red Hat. And so our team works and we create new checks as needed that run during both the build and the release pipelines. Some of these checks are a bit eclectic, so like they're different needs. So one month we'll have to implement a check that checks the catalog image, and the next month we'll have to implement a check that scans for FIPS compliance. So we want to talk about FIPS. We want to talk about our experience implementing a new check in our build and release pipelines. So we'll talk about what is FIPS. FIPS 140 FIPS are Federal Information Processing Standards. FIPS 140 is the particular standard that we'll be talking about. Some terms, the process of getting your container image validated for FIPS. And then I'll hand over to Yash. He'll talk about some open source tools that we surveyed for writing this new check. We settled on one called Check Payload. And Yash will also share some of the best practices and strategies for CI/CD pipelines. Out of our own experience implementing, we were brand new, basically, pretty much. Brand new to what FIPS is and the tooling required to check it. So first, what is FIPS, or what are FIPS? Federal Information Processing Standards. So this is a program run by NIST, and they publish a series of documents. So you can see on the screen there, I just went right to their website. Those are the most current documents. So actually, if you've been to some other lectures here today, they've discussed some of the ones at the top there for quantum crypto standards, 205, 4, and 3. But we're going to be concentrating on FIPS 140 standards. So these standards are mandated for federal agencies in the U.S. government. So if you're a contractor for the federal government or a partner, you will need to adhere to the FIPS 140 standards.
But also FedRAMP or
Absolutely, yeah. Third party, yeah, exactly. Private sector, especially like finance and healthcare industries, also use these standards, particularly for the HIPAA or in healthcare, or PCI DSS, the credit card network industry. So these standards, FIPS 140 anyway, and many of these other documents sort of are a framework for secure technology and cybersecurity practices, if you haven't heard of them before. They're also not just US based. I mean, FIPS in particular but they also refer to standards by the ISO, drafted by the ISO, and the IEC, so that's the International Organization for Standardization, and the International Electrotechnical Commission. So these are, FIPS proper is US, mandated by the federal government, but also referred to internationally as well. So as I stated, we're going to be talking about, we were tasked to check FIPS 140 requirements. So that's security requirements for cryptographic modules. All right, so there's two standards out right now, FIPS 140-2. It's been superseded by FIPS 140-3. And those certifications for FIPS 140-2 are still good for another year until September 21st next year. What is meant by a cryptographic module? So it could be, you could get something certified as a cryptographic module, whether it's firmware, hardware, like a firewall, a router, or a switch, or software. And in our case, since we're talking about building containers, we're concerned with software modules. As an example, I put down there, you can see these are actually packages on my own laptop here, or a container image I was running. OpenSSL, FIPS provider, that's a RPM package basically, or Network Security Services 3. And I just threw in a screenshot there, so you just do RPM-QI. It's just a module we're talking about, a package. Now NIST also runs this program. It co-runs it with the Canadian Center for Cybersecurity. So again, it's not just U.S., it's international. So the labs are accredited, and you get you submit your modules with these laboratories in this cryptographic module validation program. Another acronym. This won't be on the quiz at the end. Maybe the next one will, but the CMVP anyway is a program that's run by NIST and the CCCS, and you, as a vendor, it's like Red Hat or whatever your company, you will submit your module to an accredited testing lab. CSTL, Cryptographic and Security Testing Lab. You'll read in their literature. So, and also the diagram here is right from, actually NIST has great documents and a website. You can find all kinds of information. This is from one of their guides. Okay, so this is the flow of submitting one of your modules to get accredited and to get FIPS certified or FIPS validated. So the accredited lab, you submit it to the accredited lab, you pay money, there's a contract, you sign a contract, do all kinds of paperwork, I'm sure, and they will test it in their certified laboratory. Any problems, you'll go back and forth with them. Then they will prepare a report, they will submit it to the CMVP, and at that point they may go through it and approve it, or if there's anything that they need to discuss or anything that they think needs to be fixed or retested, they will go back and forth with the testing lab. So finally, when you're approved, you get a certificate and you're listed on their website. You know what? I'm not gonna visit the website just in case there's a problem with the link. But there's links in here when we share the presentation. You can go right onto their website and look at certified modules. So if you're a purchaser for software and you want to go make sure that the company that your vendor is indeed certified, you can go right onto the NIST website for that. All right, some terms here. FIPS validated. Okay, this means that your software module has gone through the testing program, through a testing lab, submitted, and CMVP has issued a certificate. It's the only official term. And then there's a couple phases that your module could be in before it's validated, and that could be implementation under test and modules in process. So implementation under test is the term they use for when your module is still being tested by the accredited laboratory. Modules in process means it's been submitted by the lab to the CMVP and they're reviewing it. So you could tell your customers, yeah, we've submitted it, it's in under test, or it's in process. And the links there that I put in, if anyone's interested, is you can also search by vendor and check and see if they're listed there. Although these two phases are optional, a vendor may not want, for some reason, to be listed there. But the final validation certificate, I think everybody is listed there. So another set of terms, designed for FIPS, or FIPS compliant, or FIPS compatible. So what does that mean? It means that your module or your product that calls this module is designed to rely on a validated module, that's been through the program. Or it's in process. If it's not validated, it's in process or under test. So those are maybe more marketing type terms. It could also mean that your product will run in a FIPS-enabled environment. So that leads me to the next set of terms, FIPS-enabled or FIPS mode. So let's say you're installing a Kubernetes cluster, or like OpenShift, or even RHEL, or some just a single server, and you put it into FIPS mode. That means that it's only going to use FIPS validated algorithms and issue all its certificates. So it's done all at the beginning. So your software, whether it's a container image or something else, if you're going to try to run it on a FIPS validated or FIPS enabled mode rather, it could, if it's not designed correctly and tries to call an unapproved algorithm, it might crash. So there might be situations like that. So that's a FIPS enabled or designed for FIPS system would still survive and run in a FIPS environment, or it's actually going to use the validated modules. Okay, so let's pivot to Yash. He's going to talk about, so we're a part of a team that's written a new check for validating container images that have been built to be FIPS compliant.
Thank you, Nate. So Nate here explained us all the FIPS related terms and abbreviations, but when you're building a container, what does it actually mean to make sure that it's going to run on a FIPS enabled environment, right? Now there are a bunch of open source tools available that you can use to verify before shipping your container that it would indeed work on a FIPS enabled environment. Each of those tools are use a different approach at verifying FIPS compliance, and we'll dive into one of those. But here's what we found. So check payload is one such tool that gives you static scanning capabilities, and it essentially takes a proactive approach by scanning the binaries in your containers and validates that your build configurations and crypto modules are up to FIPS standards. Then there are pre-validated images by companies like ChainGuard and Docker, and you could use those as base images for your container. This approach just gives you a good foundation and makes your FIPS validation check more likely to succeed, essentially. And then there's also SpectroCloud's FIPS Validate, which allows you to scan an entire live Kubernetes cluster with all your deployed images and endpoints, service endpoints. We have integrated check payload in our pipeline, and so we're going to give you some more information about how and what check payload does. Again, it's an open source tool. It scans your ELF binaries for, I know most of you are already aware of what those are, but if not, then there's a standard blueprint for programs on Linux systems, to put it in simple terms. Like, it's much more, there's much more to it, but yeah. So if you see the image on your right, that's the architecture of the tool. It takes 4 primary scan targets. It gives it to a scanner, which runs through your directory tree, extracts all the paths for the executables, and then passes on to the validation engine to validate, to make sure that it meets the FIPS standards, and then prints out the results. First one, scan payload. Now that's for an OpenShift release payload. It's very specific to OpenShift, so we wouldn't dive much into it. But there are other targets that it can take that are more applicable to everyone in the community. One, scan image. Scan image is capable of scanning a container image or an operator payload, a Kubernetes operator. So operators, I like to think of them, for those who aren't aware, I like to think of them as a robot that can help you install, manage, and sometimes maybe even fix your application on a Kubernetes cluster. Again, I'm trying to put it in very simple terms. But yeah, it's, again, in essence, a container image, but it points to other container images inside it. So that's an operator. But scan image, command can essentially uses Podman to mount the image on your machine, and then again it walks the directory tree, emits the paths for executables to the validation engine. Scan local is something similar to scan image, but it allows you to scan a locally unpacked image on your machine. It is especially useful for shared CI/CD systems where you do not want to give root permissions to Podman to mount the image, and so that's something actually we have used. And then there's also scan node, which allows you to scan the entire root file system of a RHEL or a CoreOS node, and yeah, it verifies the compliance for that. This is an example of a check payload scan local command. As you can see, it just goes through the image and just spits out a result that you can consume in a CSV format or JSON, or supports multiple formats. But yeah. So what does the validation and sorry, please go ahead.
So it's scanning for anything that's executable that it finds?
Yeah. Especially
How does it know that something is executable? What's the metric?
Yeah, so the question is that does it scan all executables, or what's the metric? So it looks for standard paths for executables, and then passes on to the validation, and it has a list and just goes through them and makes sure that these places are there.
By path?
Yeah, by path. Yeah. So yeah, please go ahead.
One of the debug flags, you can actually see all the paths that it scans, whether it's successful or not. It'll just emit them, they say.
Yep. Thanks, Nate. All right. So yeah, please go ahead.
Does FIPS committee dictate which paths, or is this up to the vendor to volunteer and state on your own?
So the question is, does the FIPS committee dictate which paths, or it's up to the vendor? So I think in this case,
It's not according to the FIPS
yeah,
standard.
yeah,
It's any executable is they're going to make sure that by examining the ELF metadata that it's been built correctly, so it's going to call the correct library for crypto library, basically.
yeah. Basically calling a FIPS validated library and not using its own, statically linked one, and not bringing its own crypto libraries. So that's what the validation essentially does. We're just getting into it. So there's a universal check that happens for all scans, which is it verifies the presence of OpenSSL library in standard system paths, and it also looks for presence of FIPS symbols to. But this is like this happens in all scans. Then it scans Go-based and non-Go-based ELF binaries separately. There's a challenge specific to Golang binaries. We'll get to it in a second. But for non-Go-based ELF binaries, it verifies that those binaries are dynamically linked and not statically linked. So like, again, as we just talked about, like they're not bringing their own own crypto libraries into the application. So this is to maintain like a chain of trust. I like to think of the difference between dynamic and static linking is that imagine you have an apartment building with all the apartments having its own private set of books that are not shared among other apartments. That's what I refer to as static linking, while dynamic linking is you have a shared library across the apartment complex and everyone has access to them, to put it simply. This is to maintain the chain of trust that, your application is using the FIPS validated OpenSSL library provided by the OS. And then for Golang binaries, it presents a unique challenge for FIPS compliance because the language's default behavior is to bring in its own native cryptographic implementations which are statically linked, right? I do have to mention this, that beginning Go 1.24, the Golang's native binaries can operate in a default FIPS mode. Their module is still in progress. It hasn't been FIPS validated yet, but yeah, you can find it in this link, which links to Go's official website and gives you all the information about what happens starting Go 1.24. But yeah, to address this, check payload enforces a specific build pattern known as the boring crypto or the Go toolset methodology. What it essentially does is performs a bunch of checks. It validates the Golang version and the compilation metadata to make sure that you're using a FIPS-capable Go Go tool chains, validates that CGO was enabled while you were building, and also looks for the presence of the CGO init function, which is again a low-level confirmation that CGO was indeed used during the build. Again, the same standard check of making sure it's the binary is dynamically linked. So static linking essentially, prevents that runtime OpenSSL integration. And then it also checks for any, conflicting tags being present in your build, like, no OpenSSL or things like that, which could interfere with running on a FIPS-enabled environment. So what are some of the best practices that you could follow while integrating FIPS scanners in your pipeline? Is consider shifting left. Run these checks immediately after your build to make sure you get a quicker feedback. You can fix things quickly before, and prevent any last-minute delays in your release or pipeline. And then we recommend using FIPS-ready base images, as I mentioned earlier, that it just gives you like a good base for building your application on. Now, there's a small nuance here that a FIPS validated base image, let's say you're using a Red Hat UBI or ChainGuard, the certificate is issued to Red Hat or ChainGuard and not to you. So if you're using it in your container, you can claim that your container leverages a FIPS validated base image, or it's FIPS compliant, or it runs on FIPS enabled environment, but you cannot say that your container is FIPS validated because the certificate belongs to Red Hat and not to you. But it's always good to clear it up with legal before using those. And then one important thing is you should complement and not replace vulnerability scanners. It is important to understand that FIPS scanners do not scan for CVEs. They're strictly checking for FIPS compliance and nothing else. I mean, at least check payload doesn't, or the ones that we've come across. So yeah, here's one way to do it. We're not saying it's the only way to do it or it's the best way to do it, but this is how we do it. We use a step action, a Tecton task essentially in our build pipeline, which is again an open source pipeline, Conflux, to scan these container images before shipping them. As you can see, this is a screenshot from our pipeline. We run it alongside other scans immediately after building the image. And this is a snippet from that step action I was talking about. Again, you can see we use Umochi to unpack the image locally. Now, this is calling back on to make sure that commands like podman mount often require root permissions. I promise I'm not trying to besmirch the good name of podman. It's just, I know they're here giving talks somewhere, so yeah, nothing against them. But yeah, we unpack it using Umochi because we have a shared CI/CD pipeline, and then scan it using check payload. And the results are then gated using Conforma, which is yet another tool that leverages the open policy agent for policy validation. And then eventually, if everything's green, you just go ahead and yeah, cross your fingers that it'll work. But yeah, to summarize some of the key points from this presentation, I know we've thrown a lot of abbreviations at you, but FIPS compliance is crucial for federal agencies, contractors, partners, also in other industries like healthcare and finance, like Nate mentioned earlier. FIPS 143 supersedes FIPS 142, and it ensures your cryptographic module integrity. FIPS validated is the only official term in the industry. Everything else is kind of skirting around it. Open source tools are available for validating FIPS compliance, and check payload is one such tool. Again, it's open source, so if you need any enhancements or anything, please feel free to contribute. The links are there at the end of the presentation, so after you have access to the presentation, you can go ahead. And then, yeah, importantly, integrate FIPS scanning early in the CI/CD pipelines. So again, a good practice here. We're ready for any question answers and discussions. So even after the talk, if you have any questions, here are our email addresses that you can always reach out to us on. If you don't know the answer to it, we promise we'll put you in touch with the people who do know and help you out. So yeah,
Any questions?
Thanks. So thank you. Actually, it's interesting because it kind of relates to the process that I was talking about earlier. So when exactly do you interject this type of test? Like, would you say this is the Red Hat build pipeline? And like, can you describe a little bit of the workflow? What comes in and where does it go?
Yeah. Oh, sorry. Okay. So the question was that where do you exactly integrate this check? Is it in the Red Hat build pipeline? And what comes in, where does it go? So great question. It is indeed the build pipeline. We run this check immediately after the image is built. And if it fails, if the check fails, the Conforma policy validation holds it right there, and you wouldn't be even allowed to, trigger a release for that. So yeah, early feedback. The image is taken as the input, as I showed in the snippet. It just unpacks the image, and then we scan the image there and there and provide the results back to the team that's trying to ship their container.
To clarify that, so the input source. It's like every operator, every single thing that tries to go into, let's say, a new OpenShift release, every operator has to go through this.
Yeah.
And so also, what's the process? What happens with this when it fails? Who knows about it, and how do they get it fixed?
Yeah. The question was like, what's the process? Who knows about it? How do they get it fixed? So every product team or whoever's building the container has access to the pipeline. The moment it fails, they get a notification. They see that their pipeline has failed. They see the logs as well as to which images specifically failed. The input is a container image that goes in, and we have labels in our system that if you claim that your product supports FIPS compliance, the task will look at it from that perspective and run that scan, run that check payload scan. But if you're not claiming FIPS compliance, the task is smart enough to identify that and just let you through. So that's it goes. That's how it goes. Nate, do you wanna add something?
I don't want to. We won't go into if folks aren't familiar with what operators are. But we're checking the operator bundle metadata and looking at all the related images listed in there, and those are the individual images that get scanned. So that's a little bit more detail.
Yeah, thanks. Thank you.
Anything else? Anybody else? Yes, sir. Throw him the mic.
I know that the FIPS 140-3 allows for PQC, but it's really weird because it says allows for. How is that impacting a lot of what's going on right now? Because it's like things could end up being 140-3 compliant, but then end up not being allowed because then they're not PQC compliant.
All right. So the question is, FIPS 140-3 mentions PQC protocols, but does it require it? I do not know. We could, I don't know if we want to. You could go right to the standards. It's really, I wonder if, I wish I had my mouse. Like, will this do the right thing if I just click? Ugh. Okay. All right. So the website's really cool. This you can download the actual document here. They have related documents and standards. And what I would do to answer that, I would click on the link to download the document, look inside, and it would probably refer to another FIPS standard or another document like from the ISO or something like that. when you click on and you look at somebody's certificate for a validated module, part of that reporting that it shows will show all the protocols that that particular module was tested and validated for. So, or algorithms rather. Anyway, I hope that answers your question. Okay.
If I may add to it, like the check payload in its current state, I don't think it handles the PQC validation for FIPS. So yeah, we're not checking for that at the moment. So, but it's a good question.
I was going to suggest there's going to be a talk at about 4 o'clock exactly on the topic of PQC, which will cover FIPS algorithms. So reserve your question until
today. It mentions it. That's cool. We thought we were all alone. But there's a lot of other talks touching on this subject.
Any other questions?
Thank you very much for listening to us.
Thank you.
three. You ready? Yeah, it's good. There are no speakers in the room. You're good?
Hi everyone, welcome to the talk on unveiling remote code execution. Our presenter today is Suyash. Suyash, do you want to take it over from here?
Yeah, sure. So welcome everyone, and let me start by asking the question that we all like. Am I audible, everyone? Yeah, all good. So yeah, welcome everyone. Today we are going to lift the curtain on the one of the most scariest kinds of security flaws. It's RCs and ACs, remote code execution and arbitrary command execution. We'll discuss how they work, but also we'll discuss why they are so dangerous and one of the kind of like they are scary. Like you can get your machines hacked by attackers, and we'll deep dive into this. I will also share what you can do to stay protected from these kind of security flaws. Then we'll also walk through some of them that I had the opportunity to fix in the RHEL versions. And then at the end of the session, you will know how attackers pull these stunts and how they take over systems and make use of these exploits. So yeah, sorry, I forgot. My name is Suyash and I'm from Red Hat, and let's get started. So the session outline. Today we'll be discussing arbitrary code execution, remote code execution, some of the popular vulnerabilities that I had the experience to fix and deep dive into. Then we'll have a demo. I'll try to do a live one, and I also have a recorded one. And we'll see some statistics and some of the greatest hits that RCs were able to do, like attackers were able to pull off some serious stuff. And then there are resources on the slides to, if you want to check out the blogs and the resource pages for all these exploits. And then we'll open up for question and answers. Okay, so setting the stage right. The left screen, you'll see how Hollywood thinks like the attackers or the hackers are sitting and typing furiously on their keyboards in dark rooms. But in reality, it's not true. Like people that take over systems or the attackers, they are people who know how systems work, how data is analyzed, and how systems analyze data and make use of their databases and everything. So in short, attackers aren't magicians or wizards. They just have good understanding of computer systems and networks. And yeah, reality exploits are technical flaws in code, and these attackers leverage these predictable weaknesses and make use of them. Okay, next thing, arbitrary code execution. So arbitrary code execution is a whole umbrella of different attack vectors, and it is kind of one of the most popular ones. Like it is not easy to come by. It is kind of a rare security flaw. But yeah, ACs, arbitrary command execution, you can run these commands over the server. But for a normal arbitrary command execution, you need to have access to that server in a physical mode. You can, like when you see in the movies that the hacker goes to an office and goes inside and plugs in keyboard and then types commands, that is AC. So to give an example for people who don't have quite a good idea of these, imagine your laptop assistant, Siri, Alexa, whatever you use. Yeah, these assistants know commands like open my music, show my calendar, right? So imagine if there is a glitch and these assistants don't see what you are asking it to do. Yeah, like if I say open my music, it will open the music app and play music. But imagine if they are not sanitizing the input that the user is giving it to, and a sneaky person says, oh, delete all of my assignments, share my pictures over email to everyone. That is AC, like that is arbitrary command execution. The system that was supposed to sanitize the input did not, and it in the end, the attacker was used to execute commands that were not supposed to be even done. Yeah. All good then. We'll move to remote code execution. This is the main topic of the talk. When you say remote code execution, it's similar to arbitrary command execution, but the only difference here is that the attacker could be sitting in any part of the world, and without even being present in the server room, they could access your systems and take your data, delete it, do it, run commands, and do things that they want to. For a basic example which I shared before, like the assistant, like imagine you got a brand new TV, right? You get a remote with it. Now that remote, it lets you control your TV, do things that you are supposed to do, right? Change channels, adjust the volume, and do streaming and things. But imagine if there is a magic remote with a person that is sitting in any part of the world that you don't know, but they do have access to your TV. They could at any time change the channel or blast the volume, and you are sleeping. Imagine you are sleeping at 3 a.m. and they are blasting the volume at 3 a.m. So this is how RC works. The attacker could be placed in any part of the world, and they could execute commands on your system, and you won't even have an idea that they did something like this. So that's essentially what RC is in the world of computers. And in simple terms, you give a magic remote to an unknown person that is allowed to run commands and on your systems. Then, yeah, now, as I said, I worked on a few of these CVs that I could deep dive into and research about them. One was Python setup tools. We know Python developers and some of others also. This tool is used to install and build Python libraries, packages, and it is basically present in all of the systems. So what the issue was that the Python setup tools did not sanitize the URLs. So if you put a URL while downloading the package, there's a URL that you are supposed to get it. And the Python setup tools did not do that. So if you, let's say, an attacker could make a malicious URL and post it to a library, and they could, if you pip install it, you could get malicious code on your system, and they could have access to your system. This was fixed very fast, and they did it quite well. So what's the learning here? Setup tools lets attackers sneak in malicious code, and this means if you download unknown libraries, your machine could get attacked and hacked. Moving on, Git. Git is everybody's dream. Git had a CV itself, and the flaw came from specially crafted repositories. Like if I'm an attacker, I could specially craft a repository. I would have malicious code into it. I would have created symlinks to other files, and I would clone a repository. If I put that repository into GitHub and a normal user clones it, I could make sure that I run my own commands. I could run, I could do anything with that commands, and it is just basic cloning stuff. It's not that difficult, or this is something that we do every day. So even a Git clone could mean your system could get hacked. So yeah, if you are tricked into running Git clone on unknown repositories, unknown packages, don't do that. It is always safe to rely on verified packages. Then this is what we'll discuss in detail. This was a bug that was found in CUPS printing systems. So CUPS is a library that is used by all of major Linux distributions to manage printers, add them. They have drivers for it. If you submit printing task, it will go through the CUPS library, and then it is sent to the printer that is remote to the server. So if you're let's say if you have a machine and you send a printing job to a remote server which has a printer attached to it, like we have in our offices, like you just print it somewhere and your printer picks it up. But imagine if the printer that you are sending the information to is a malicious one. Like if I post a printer saying that okay, I'll explain it in detail later, but this is the CV that we'll discuss in detail. It was a very critical vulnerability. It was rated a 9.9 CVSS score on multiple domains, and it was able to make attackers take complete takeover of the systems. So yeah, how the vulnerability works. So CUPS has these filters that is uses to make prints, add the printers, add printing drivers, and make schedule jobs and things like that. So what an attacker did was silently you could replace the IPP URL. IPP is a protocol that is used by printing servers. So you could replace the IPP URL with a malicious one, and the printer, the client where the CUPS library is installed could return back information that it is not supposed to do. So there is a port, UDP port 631, that was left exposed without any authentication. Like you could just make any request to it and it won't authenticate you. It will just accept that request and perform the things that you tell it to do. Yeah. So I'll move to the demo. Okay. Oh. How do I do that? Yeah. Okay. Yeah. So here is the CUPS client that I have. You have CUPS running. Is it printing? Oh, it's down there. I don't know how it is. So yeah, you need CUPS running, and you need, okay, why is not a, and you need this is running slow. I don't know why it is happening. CUPS. This is the CUPS browse service that is used by CUPS to add new printers, add drivers and such. So this is the client where CUPS is installed, and I have a few exploit files that I'll be using to exploit this CV. I did run. Okay, so there's a small script that I wrote that will send a payload to the CUPS client here on port 631, and we'll see that it created some temporary files into this system and here. So if I get this file and do this, oh, you have these commands that get executed on your system. So what it does is this attacker machine sends payload to the client machine. It will connect back to the attacker machine because there is no authentication on the UDP port, and it will take on the data that is sending. Like on the exploit file, if anyone wants to see the exploit file, I'll show it later in the end. So in the exploit file, we are creating a new printer that is having attributes similar to what they exist in normal standards, but in the end we are using commands that will be sent to the server, and if the attacker wants to, you can change the commands, I guess. So I'm just echoing I'm vulnerable on that client printer. So if that file gets run, it will execute the commands. So basically that's what we are doing here. I have a few files, but it did not work on my machine. I don't know why. I tried it before. But yeah, with this you could take reverse shells, you could scan for network, you could scan for the remote, you could scan for the usernames and the users on those remote system. You could remove databases, add any commands that you like to, and you could execute them over the remote connection. The problem with this, I think we'll move to the, I know it was a short demo. I have the files and everything ready, but it's quite big. Okay, yeah. Talking about why this happens. The UDP port 631 is open without authentication, and there's a filter called as CFP printer get attributes. So that filter, it's very old, and there are printers that still use it. Like there are printers from 1990s, 2000 that use that particular filter, and you could just not make it stop. Like you can't just remove it from the CUPS library, because if we remove that, your other printers that are very old, that will become unusable, like they will become trash. So what we did to fix it, that we sanitize the input that is given from the user. We blocked the UDP port, like it was accepting all of the connections. It will now just accept the connections from your own network, from your own what do you call it, from your own from your own LAN. So it will only accept connection requests from the own LAN, and some of the few regionalization stuff, like if you look at various languages, then you will also have to add support for different languages. So there were some additions to different languages, and they have basically, we did sanitize the inputs. So I hope that was. No, it's not unauthenticated. We moved it to the local LAN.
The LAN is trust. It's not authenticated.
Yeah, but you cannot do that because it will make other printers unusable. Like it.
Microsegmentation within your local area network, so that where you either have internal firewalls, or you have VLANs, or virtual LANs, or you have basically secured local VLANs, so that you can segment off that part of the traffic. Different subnet of IP addresses. There's multiple ways that you
Okay.
try to minimize impact.
I'll look into the upstream contribution that was done to see if we could do. So the question was that it is still authenticated. I'm doing for the camera. So the question was that is it still unauthenticated? Yeah. So the answer is it's not yet, but we did fix some issues that could lead to system takeovers. The CV in all is 3 CVs that you exploit at once could give you access to the remote RCs. So if 1 or 2 of them are fixed, then it does not. Like there's a CV in CUPS browse, there's a CV in CUPS filters, and there's a CV in CUPS, the original thing. So in Red Hat, like what my team does, we fix the one in CUPS browse and we fix the one in CUPS filters. So CUPS was not useful then. Okay, so this is the recorded demo. Yeah, now moving to the greatest hits of RCs. Yeah, there was a security flaw in Log4Shell, the library that is used by Java applications to log information from their system applications. So because Log4j shell was used in like millions of applications, the use case of this CV was widely applicable. Like attackers, it was a very easy attack. You just needed the developer to have used a string, like some specific strings in the application while logging, and the system was available for takeovers. So key takeaways from the Log4j shell CV was that you should not log untrusted inputs, and it can become remote code execution. Moving on to the next one, there was a WannaCry spread in 2017. It was using the Eternal Blue exploit leaked through Windows, and it literally encrypted files like a worm. It moved to your directories. It crawled your directories, your files, and basically encrypted them. And because of this, it had a huge impact. It locked out businesses, it locked out governments, it locked out banks, hospitals from using their own files, and they had to pay ransom to make those to get access to these files. So yeah, and the important thing here, that there was a fix that was sent by Windows, but a lot of people did not apply the fix. So make sure that when the vendors of your systems give you the fixes, make sure you apply them. Yeah, some statistics. There are a lot of attacks happening today. Like an average breach could cost any organization around about $4 million to $5 million. There are supply chain attacks, like they disrupt supply chains from the companies that ship products. So if they grow at this stage, the current problem with this is that they are projected to grow double. Like the current amount is $46 billion this year. It is projected to be $81 billion next year. So attackers are kind of making huge problems for these companies. And if you talk about real world cases, there was an attack on Marks and Spencer, the clothing brand, that cost them 300 million pounds in profit hits. And there was a company called Arup. They lost 25 million pounds to a deepfake fraud. So what do we take from this? That you need to prevent these attacks in order to make your systems running and they do not disrupt your processes. Okay. That was it. Yeah.
I was going to say, if you have a large company or a company that's been around for a while, you're going to have legacy systems, and you're going to have software that can't be updated, or you might have OT, operational technology, cybersecurity, where you cannot go and quickly and easily make system updates. So you're going to have these obstacles where you, as you mentioned before, with the printers, you might have older printers, and that if you do make an updated change, you will selectively, cut out, that part. So you might have to take a look and say, okay, how can we have this functionality and then still have security, and find that balance between the two?
Yeah, I'll just repeat the question for this. So the question was that how do we balance the functionality and the security of old applications on old systems? Is that right? Yeah. So like my team specifically works on it. Like I don't know, we are supposed to talk about our companies, but my team specifically, what we do is that we make sure that the companies that use these old legacy products are secured through security patches. We ship security patches for all of these packages on Linux distributions. And I think from my perspective, like what I have seen till now in my 2 years of career, it has been a short career. I know you would have more information on this, but people do discard these updates. Like it is sent for these companies for a reason. Like they just don't think that it is important to them. And there are a lot of obstacles present in, like, let's say banks. Like banks, you need to evaluate each update, like what the change was and what the update fixed, and then only they are allowed to use that specific library. So companies or institutions need to find the perfect balance over security, and if they want to upgrade to a new system, like it's a big challenge. That's why we support all older RHEL versions as well. But in the end, like, Linux is kind of open source. Like there's code that is available open source for everyone to exploit. Like you need to just see what the exploit is. You need to you need to keep up with the attack vectors, and then you can just exploit them. But on the other side, I think developers should also keep checking out what people are doing, what the current security flaws are in their market, and if they are using applications or libraries that that could impact those that could be impacted by those CVs, then you could fix them or implement security measures to fix that. Does that answer your question? Sorry.
I mean, it's nice in theory that you feel, okay, we just send out the patches and they will automatically get deployed. But the real life situation is usually you'll have old software that cannot be updated. And
Yeah.
you need that to keep running your business. And so when given a choice, upper management will make the decision of having the latest and easiest for making money making.
Yeah. Legacy software. I think that's a quite tricky. Like
Yeah.
it.
And then if you're in a production environment or utility environment, you are in a environment where you cannot. It has to be 100%
Yeah.
uptime.
Yeah.
You
Yeah.
don't have change control. You don't have scheduled down windows where
Yeah.
you can make updates.
Yeah.
Or automatic updates are not an option. They're manually applied.
Okay.
So you will have obstacles with
Yeah.
your business environment, depending on what your industry is or what your
Understood.
environment is. And the support from the higher ups.
Yeah, I did not think of this scenario, but yeah. No idea. Do you have any other questions?
No more questions.
Sorry.
Oh, the word you were looking for was rubber ducky.
Yeah.
Yeah. So you weren't talking about ACE?
Yeah. This one.
Yes, ACE. So the word you're looking for is rubber ducky, where you see someone come into the action movie and they take a USB and they plug it in to the computer and like they start uploading, it's the rubber ducky. So the thing you automatically want to do in your company is harden all the computers, so software developers can't create code on their own computers. They have to do it in a secured environment, either in the data center or the cloud, and that way you have a more secure SDLC.
Okay. Yeah, makes sense. But Red Hat being Red Hat, I could plug anything into this and download anything, upload anything.
Well, that's where we have a hardened Linux,
Yeah.
where when you roll out a gold image, you say, okay, this software is no longer available to you because we've removed it from your when we rolled it out to you. Yeah.
I think that would make sense for production systems very much, but I don't know company policies to change. Like,
well, that's where you have to have a company policy to say, okay, depending on your role, you will have these features, on your computer, and depending on where you are, it's called least privilege and zero trust. Yeah. All right.
Any more questions in the room? Okay, well, thank you,
All good?
Suyash.
Yeah, thank you. Can I click a picture with everybody here? Yeah. If anyone has any questions or want to see the slides, resources, I have uploaded them to the Retailex schedule. You can just go there and click on the links.
Arthur Savage with us, and he's going to present a talk on post-quantum cryptography for digital signing. Take it away.
Thank you very much. All right. Hi, everybody. So I am Arthur Savage. My pronouns are he, him. I am a software engineer at Red Hat, and my project is in post-quantum cryptography for digital signing. I'll be talking a little bit about my work in open source in this area. I hope you'll find it as interesting as I do. So there have already been some really wonderful talks today that discuss the basics of post-quantum cryptography. I will cover them as well, and I'll try and keep it brief because I would like to get into some of the newer, more exciting stuff, what's happening right now in open source, and with a project that is near and dear to my heart, SigStore. So we'll start from the top then, I suppose. Right. So cryptography is pretty important. The entire internet runs on it. All of our most secure systems, financial, government, and it's used in a variety of different ways. Obviously for things like networking, so TLS communications, we use it for digital signatures so that you can verify who wrote what, and also data encryption. These are all different standards for all of these things. And when you look at it as a whole, you think of it as public key infrastructure. And it involves a lot of different algorithms, different working pieces. What we're going to focus on is a classical cryptography, as in RSA and elliptic curve encryption. You might know them as asymmetric cryptography, public-private key cryptography. They're all different ways to describe the same thing. And they rely on similar mathematical tricks. So integer factorization, such that the computer on your desk or your phone can multiply two integers easily, but cannot factor them if they are prime and large. And that is the primary math trick that most of modern encryption relies on. But as we will see, quantum computers kind of throw a wrench into that. So I will not try and explain how they work. I would embarrass myself in attempting to. But the most important part is that they are non-deterministic. And they open up a whole class of non-deterministic algorithms that can leverage parallel computing in a way that even GPUs cannot. They're good at calculating a lot of different possibilities simultaneously. And that has interesting implications for stuff like hyperparameter tuning, really complex simulations, and spoiler alert, breaking encryption as well. It helps that they're hard to build. Quantum mechanics is difficult, if you'll believe it or not. But they're getting larger at an alarmingly fast pace. Specifically, so, when I mention quantum algorithms, Shor's algorithm is typically what we talk about when we think about, what will break classic encryption. Anything that is related to like Diffie-Hellman, RSA, elliptic curve, they are all vulnerable, which means that the backbone of modern cryptography, as soon as quantum computers are large enough, will essentially no longer work if nothing is done. The footnote here is that not all cryptography is vulnerable. So things like symmetric or block ciphers, so your disk encryption will technically still work. It is managing keys that becomes insecure. So like AES is not considered vulnerable, and one-way hashes like SHA hashes should still work. They do become weaker. Like Grover's algorithm specifically speeds up finding hash collisions. So it's not invulnerable, it's just still considered computationally infeasible. And we say that a lot, and computers keep getting more and more surprising. So something to keep in mind for the future. There are there's one attack you will hear about all the time, and it's harvest now, decrypt later. Essentially, you can think of it as scraping the entire internet and then figuring out what you want to decrypt when you have a computer that's large enough. This is already happening and has been happening for many years now. So we consider that an active attack, even though no one has yet admitted to having a quantum computer large enough to break current communications. Something that is not really talked about enough is digital forgery. So at the same time as communications can be decrypted, digital signatures will also become, how do I say that, repudiatable? It violates non-repudiation. Am I saying that word right? You can, essentially digital signatures will no longer be valid. Obviously, there's an asterisk here, so like you can kind of infer which signatures might still like have been valid at the time that they were made. But obviously, that's not how we like to do cryptography, so we have to do something a little better than that if we're going to maintain the integrity of the software supply chain. Oh yeah, so in case anyone in this room wanted to feel old, I was 4 years old when Y2K happened. So I don't have any exciting stories, but my dad sure did. My family has always lived in like rural areas. So, you know, typically in the dead of winter, they're kind of like no one's there because it's cold and there's nothing to do. But miraculously on New Year's Eve, the turn of the millennium, everyone was in the middle of the woods. And that's because there was a lot of misinformation about what was going to happen for Y2K. For those in the room who are younger than me and may not be aware. Oh goodness, hang on. Yes, oh my God. It was missing my little Y2K. Okay, oh goodness, what was I saying? Yeah, so, right. So, yes. So Y2K, the like 2-second gist is that dates, there wasn't enough, like that the clocks could not accommodate the dates beyond New Year's Eve on 1999. Yes, I can speak. But there was a huge engineering effort to make sure that the worst of the problems from clocks turning over would not, you know, cause the world to fall apart. And because there was that kind of anticipatory engineering effort, the Y2K is kind of remembered as a nothing burger, which is a very good thing. It's a success story. Okay, good. That showed up this time. Yes, please.
Because of the software, it was had 2 digits instead of 4 digits, and so when you get past, 1990, you get to 1999, and you're only doing 99. It's like, what happens? Does it reset to 1900? And that's where you had to switch it from 2 digits to 4 digits, and that would solve the software issue.
Thank you for explaining that in a much more eloquent way than I was able to. Yes, I figured. Your input is appreciated.
In the data center, like, okay, what's going to happen? Let me take care of it.
Yeah, it is really cool hearing, the stories from people who actually lived through it, because like so much more qualified to talk about this than I am. But we can take the same lessons that we learned from Y2K for Q-Day, the day when a quantum computer becomes large enough to break RSA encryption. We don't know when that will be. Unlike Y2K, we don't have a precise date when dates will not work anymore. So, yes.
I was going to say, so one more thing. When people are talking about the keys, they're looking at what's the rotation time on the keys. So when you get into like Microsoft Azure or Key Vault, or you're taking a look at AWS's version, it's okay. So one of the things you can do is refresh the keys, and that way you have more of new refreshness, newer keys to compete against the increasing compute power of the quantum. Yeah.
Are you asking if we can make RSA big enough that it doesn't matter?
I'm saying, what are your possible solutions?
So, the possible solutions are post-quantum cryptographic algorithms, and that will be discussed a little later in the talk. Yes. That's all right. I'm taking the roundabout way to get here, but my point with these anecdotes is that, putting in the effort now will save us a whole lot of headache later on. Right, and let's talk about dates again. So no one really knows when the cryptographically relevant quantum computer is going to become available. It may already exist. We don't know, which is why preparing soon is very, very important. The timelines that you're seeing here are from the Commercial National Security Algorithm Suite. Recently, let's see, it was last updated December 2024, and the timeline is here. It only matters really for national security software. Like if you make software for the US government, this is what you're following, but it matters to everyone because this is what the NSA thinks will happen. And their timelines, as you can see here, is they're beginning enforcement in 3 months, 4 months? Yeah, so that's soon. With them expecting or requiring, I should say, that all national security software be completely quantum resistant by 2035. Obviously, not everybody in this room makes national security software, but these timelines matter because they can provide insight into what's going on behind the scenes. So let's talk about the algorithms themselves. So selecting them has been a huge adventure, a multi-decade effort, primarily headed by NIST. So there have been 4 rounds now, I think, of academic researchers submitting potential algorithms that might be resistant to decryption by a quantum computer. They've gone through multiple rounds of peer review, experimentation, and the result has been a set of FIPS documents that provide the pseudocode for how to implement these 2 primary algorithms in bold, MLChem and MLDSA. There is a third, SLHDSA, that I will not talk about because it is currently out of favor, as more or less these PQC moves pretty fast and standards are changing constantly. I believe they are coming up with something else. I think it might be Falcon that they're considering next, but I won't speculate too much. We're focusing on MLChem and MLDSA because those are the 2 algorithms that are kind of forming the backbone of the new post-quantum cryptographic infrastructure. So a lot of this work was done by NIST, but I want to highlight some of the international contributions and specifically talk about the European Commission. So they released a PQC roadmap for all member states, which gives a lot of freedom to individual countries of what algorithms they might implement. And there are dozens of potential algorithms that have been discussed worldwide. And some of these standards differ from what NIST has to say about what they think the future post-quantum algorithms should be. Some of them conflict, some of them are complementary, but the worldwide, cryptographic landscape is a little bit chaotic. So it's important if you are writing software for, the world to know that things are different, like worldwide, and the standards will change. We are not yet sure how. Let's see, what was I gonna say? Right. So this is the big 2 algorithms in a nutshell. MLChem is what you would use for communications. So it is to like TLS, OpenSSL. This is what they are using to replace RSA and elliptic curve for concealing keys over public channels. So that is specifically what's for addressing harvest now, decrypt later. MLDSA is for anything digital signing related, and it's been the focus of what I personally have been working on. And these 2 combined kind of fill the gap from RSA and elliptic curve. It's not perfect. Obviously, these algorithms have not been tested at large scale. They are currently being integrated into core cryptographic packages like TLS, OpenSSH, etc. But they haven't been around that long. So it's a work in progress. And PQC is not a one-to-one swap out with classical cryptography, especially they are changing all the time. I'm pretty sure one of the slides I will show you later I made last month, and it is already out of date. So like it's moving at lightning speed. And that's why crypto agility is so important. We'll talk a little bit more about that later, but it goes beyond even what algorithm you're using in that most of them are big, and having your signatures be measured in kilobytes instead of bytes has huge implications for like edge devices, Internet of Things, anywhere you have memory constraints. If you use a lot of keys and signatures, that can, like, if you have blockchain or a transparency log, it matters a lot. So these are things to consider as you are considering your future cryptographic needs. Also, I mentioned on the last slide, there are potential vulnerabilities. They haven't been tested in the same way that like RSA has. So like we could find something tomorrow, 10 years from now, we don't know. We'll just have to find out when we get there. And some of them do not behave the same way as classical cryptography, so they might have additional parameters. They might be stateful. Not all of them are, but it's something to keep in mind depending on which algorithm we all end up using. So what are things like today? You know, I kind of think of this as the wheel of chaos and misery, because ideally we would all come up with one standard and it would work beautifully forever. But life is not that simple. What we see is the multiple rounds of algorithm standardization. You know, NIST produces FIPS documents, and then open source implements them somehow, and then your applications will get those algorithms, and then something will change, and round we go. And it means that you might need an algorithm before it becomes available in a core package. And that's kind of what we're seeing now. For example, like, let's see, so Golang has lagged behind a little bit with MLDSA, but has done MLChem first. So you can see it's kind of staggered. And that's not like a Golang specific thing, but you will see that different algorithms are becoming available at different times. So if you need something sooner, you might find yourself at an impasse, which is what a lot of open source is dealing with right now. This is actually the slide that I was saying was out of date. This was July. There's a new one every month. But you can kind of see that the implementation internet-wide is a little bit patchwork. They're all happening at different timelines. Some of them, as you can see, are blocked or stalled, etc. Like, let's see. And you will notice here that this does not include core language libraries. So, like, yes, this is kind of a look at some of the most widely used programming languages and whether they have packages available that are native that you could decide to use now. And there's not like a ton of options. I would say we have some really nice third-party packages in Go. Java has options, C and C++. But it's not like, for example, Python has no options. And like, how many of us use Python? So, yeah. Okay, so let's talk about crypto agility. It's really necessary to tackle the like growing threat of quantum computers. It's also really hard. Like, and it, we were even talking about this like in the last talk. It's so hard to change legacy systems. And when you like make big changes, it's a huge effort for maintainers. It can lead to vulnerabilities in itself. So like crypto agility is a big ask. So you kind of see this tug of war with like, you know, needing and wanting stability and also needing and wanting the ability to swap out something if an algorithm is found to be unsafe. So there's no easy solution. And I'm going to use a project that I've been working on and working with upstream for quite a while now, SigStore. Show of hands who knows or uses SigStore. Yeah, that's a lot of hands. It's an extremely prolific and very large project. For those of you who aren't familiar, the goal of SigStore as a whole is to make software signing easy, which is really critical for preserving the integrity of the open source software supply chain. It is also, like I said, very, very big. And when you have a large, sprawling system, it's hard to make changes. That's true of any project. And like this kind of brings me back to the philosophy of stability. So SigStore, as many projects do, tends to be conservative and opinionated about which like cryptographic algorithms to use. And there's a very good reason for that. A lot of really like high sensitivity projects use SigStore, so the decisions they make matters a lot. And Golang has a really well thought out cryptographic library that does not currently have post-quantum cryptography in it. And part of the reason that Golang makes those decisions is because they have, 10 years of support is what they try and commit to. So like adding one algorithm is an enormous commitment. So again, these are all very reasonable decisions, but it does create blockers when you as an open source developer are trying to integrate new cryptography into a system at more aggressive timelines like CNSA 2.0. So I spent a lot of time thinking about how do we uphold the philosophy of stability while still providing the flexibility needed to introduce PQC where we need it most. And that's what kind of got me thinking about the blockers and like how do we keep things, expedite these changes in a way with minimal, how do I put this? Having experimental portions of your system as opposed to having it be like the whole system changing at once. So let's see. Right. So I actually wanted to highlight some work done by some upstream colleagues of mine, Trail of Bits. So about 2022, they put out this software proposal to the community to introduce crypto agility into various parts of SigStore to eventually allow for the introduction of post-quantum cryptographic algorithms. That was about 3 years ago, and they've done some really incredible work. And this is all just in advance of having the algorithms available. They recently released their own version of PureGo MLDSA, which is pretty great. You can check it out. Obviously, 3 years is a lot of work to do and still not have the algorithm in your library. And that there's a lesson to be learned there that this takes time. That's why starting early is so important. And I would also like to take the opportunity to plug some of the work that my upstream colleagues have been doing too. So Zach released this blog on SigStore that illustrates the community's overall position on post-quantum cryptography. If you feel like looking it over, it's a really good read, and it kind of details what the post-quantum transition looks like for a project like SigStore. Let's see. Yeah, and then this is just a very quick overview of some of the stuff that my team and myself have been working on. So a lot of understanding how to make PQC happen has been just a lot of conversations, like GitHub issues, PRs, trying to figure out how to balance the needs of a massive community. Because I think last time I checked, SigStore had 33 repos. Was it? It's huge. So small changes have huge repercussions for clients. So asking everyone for their input is really important, and conversations take time too. We've made some initial changes to make MLDSA possible, but what we're exploring now is creating external plugins and libraries so that you can use SIG-Store signing framework with more experimental post-quantum algorithms without compromising the stability of SIG-Store itself. So just general takeaways. I copy-pasted this from NIST's website, and I thought it was really like the almost 2 decades should scare you a little bit, because this has been going on since 2016 is when the NIST competition started. That's 9 years ago. Yeah. So we're halfway into this timeline, and it's really important to not be complacent, to start earlier rather than later. And that's a tall order. We must begin now. And this is a little bit of homework for you to take away, as if you don't already have enough to do. Take stock of your cryptographic libraries. Like, figure out, what do I use? Where do I use it? How much effort would it take to change this when we have to? Educate yourself. Post-quantum cryptography is not necessarily intuitive. There is a learning curve, and it is best done together. And you can try using it too, like TLS 1.3 is now PQC capable. OpenSSL's most recent versions have it too, so you could try using it in your projects, in your everyday life. And try to make contributions if you can. Yeah, and we'll figure out when the due date to this homework is together. Right, huge shout out to all of my wonderful colleagues, both upstream and at Red Hat. Thank you all so much for attending today. Any questions?
Thanks. You have your mic back.
Sorry about that.
You mentioned somewhere along the line about the new post-quantum algorithms are like have a different parameter shape than some of the traditional ones, and I don't know, is that causing a problem for crypto agility?
It can, and it does depend on the application. So MLChem and MLDSA were selected in no small part because they are relatively easy to use in a more one-to-one fashion to classical cryptography. Like the size being the biggest difference, but especially like, so when I was talking about things being stateful, like LMS, LMOTS, those are stateful. So there are additional like management considerations if you're going to try and use them. So like it might matter depending on what algorithm ends up being used. It's something to be aware of. What worries me most is the size, honestly, as opposed to additional parameters. But it depends on the algorithm too. It does.
Like when you say size, how big are they?
So there are multiple security levels for each of these algorithms. MLDSA is somewhere between 2 kilobytes and 4 kilobytes, depending on the security level. That's big. So like it's non-trivial. And some algorithms are smaller or larger, but it does not seem, at least with what is currently available, like there will be small signatures anymore. That may become a thing of the past. But someone smarter than me will know more about that. Yes?
What they consider to be like, I guess, like coverage for like quantum safe. Do you know how they like test for like an algorithm to be quantum safe? And does it like differ from country to country? Because you said that like countries have like different standards, or are they like checking for different things?
Yeah, absolutely. Actually, so let me back up a couple. There we go. So this is actually a simplified version of the other slides I had. So there is something of a disconnect between the people who are writing the algorithms and then the governments who are like mandating which ones to use. So to repeat the question, sorry, you asked about how the algorithms are being decided.
Yeah, like how they're tested, like what
How
they're
they're
checking
tested.
for when they're looking at these algorithms.
Right. So the testing, there are multiple parts to the testing. The first is that they put out the pure math behind the algorithm, and then academics look at that math and say, hey, does this look like it makes sense? And they're relying on different hardness assumptions than the ones that are currently for RSA. So it's like different complexity. I'm being super simple here because I don't want to get into the math. And then based off what the academics say, there are standardization documents published, so like NIST, typically, and then the software is written because the standards are actually just pseudocode. So then the pseudocode gets written by some software engineer somewhere. And then the testing can be done on that code. So you can see there's multiple steps here, multiple places where things can go wrong or be missed. The math, theoretically, should hold because it's math and we know how great theory holds up in practice. But whether the code that someone writes is secure or is accurate to the theory, that will depend on the implementation, which is why things like hardening, auditing code are so critical. And when it comes to international, different regulations between different nation states, some of it has to do with the nation's political affiliations, and some has to do with their own infrastructure considerations. More or less, MLChem and MLDSA are relatively widely accepted, but some governments are saying, oh, you need to have this security level, or you need to support this additional algorithm. They're making decisions based off what their nation requires. That's why we see variability there. And it's not necessarily a bad thing, but it does make software engineers' lives harder. Does that answer your question enough? Yes. Okay. Any other questions? Yes.
So, my understanding of cryptography is that you have 3 different kinds of algorithms. You have the digital signatures, you have the asymmetric encryption, and you have symmetric encryption. It looked like the 2 algorithms you listed were just asymmetric and digital signature. Is there one for symmetric encryption?
Symmetric encryption will, if it is large enough, not be impacted by quantum computers. Because it relies on symmetric encryption, like through AES, doesn't use integer factorization or discrete log problem to get their strength from. So they are not impacted by quantum computers. There is a slight speed up because of Grover's algorithm, but essentially, it's different math, so it's not it's not vulnerable in the same way. And the same thing goes for one-way hashes like SHA and SHAKE. They are not vulnerable to quantum computers because they're not relying on the vulnerable matrix. Does that make sense enough? Yeah. So your AES is safe as long as it's big enough. Anyone else?
One last question, maybe.
And you can also catch me in the hallway. I will hang out if anyone has additional questions. Yes.
So you talked a lot about software and the increasing demands for memory, and do you see people talking about how hardware may be impacted by this as well? Or do you think we'll just keep adding, bigger storage and bigger memories and that'll take care of it?
People will only talk about it if someone brings up the conversation. And, that's why it's important to, recognize, hey, these are big, which means that manufacturers are going to have to take that into consideration, especially for hardware security modules and IoT devices where space is so critical. It's going to be a really big problem. in my opinion, because a lot like TPMs as they exist now do not have the memory to like manage MLDSA. You need a new TPM, and that's a problem. TPMs are everywhere. Yes, actually, someone did another talk talking about HashiCorp Vault. Yeah, and then Entrust, I believe, has post-quantum hardware security module. There are also there's a variety of manufacturers who are working on them now. That's like a whole talk of its own. So we could catch up a little bit more about that later. That's actually what I'm going to be looking into shortly. So yeah, that's interesting, exciting, scary. All right, thank you so much, everybody.
Now I got to get my mouse back from that screen. Found it. Beginning.
Yeah. Hello, everyone. Welcome to this talk on decoding employment inequities presented by MB. Take it away.
Thank you, thank you. First, I would love it if y'all would all like collect in the middle because there's not many of us, and I'm gonna like there's gonna be audience participation. So prepare yourselves. Also, I'm nervous. Helps if you're closer. Thank you. Okay, so my name is MB Pierce, and I manage a team of engineers at Red Hat. And let's see, we're going to be talking about career like your career progression, and a lot of this is about getting into tech or some other thing that you feel like maybe you're not quite qualified for. And so in the interest of transparency, I will share that my career path has, when I compare it to those of my peers, mine is more like Mr. Toad's Wild Ride than the rest of, like anybody else I know. Some of the roles that I've had are camp director, teacher in high school and college. I was a therapist in like a regular therapy office and in the wilderness. I've been a logistics manager, a language interpreter. I was a quality engineer and a full stack developer, and now I'm a people manager at Red Hat. So all the things and some more that I like, it was just too long to list. My goal today is to like try and get folks to think differently about how you're approaching your career, and hopefully give you some tools that will like help you make some decisions and take some actions that will get you more of what you want. So let's see. Oh, and I will also say that at any point in time, if you have questions or comments or whatever, like just go ahead and throw them out there. Okay, so defining the problem. Look at these pictures and tell me what stands out. And they're small, sorry. Yeah. I'm also seeing that the guys are the ones who are, or the people who appear as guys are the ones who are telling someone what to do, and the woman is sitting there, is sitting there taking notes. Yeah, yep. And to repeat for the microphone, everybody looks the same as the other thing that I heard? Age. Age, yes. Very defined age group. Anything else? Very sharp observation. Glasses and no glasses. So these are AI generated, and I asked Gemini, like, give me a picture of 5 average tech workers. That was the prompt, and this is what I got. So, like, the first thing that stands out to me, like, my reaction when I saw it, I was like, AI is like a toddler that's using its outside voice, sharing all the things that you said in private. Like, that's what's happening here. So beyond that, because when I tried to, I couldn't let that go. Data, and I have to believe that this is, like, none of this is new, so we're gonna blast through it. 27% of tech jobs are held by women. Black people, 4%. Hispanic folks, 8%. Folks with neurodiversity and disability are around 20% of the population, and for neurodivergent folks, only 3% are in the tech field, and for folks with disabilities, it's 6%. So wildly disparate numbers. LGBTQIA folks, the percentage of people in tech who identify in that category is higher than the average population. However, 25% of those folks report having been discriminated because of their identity. And when you look specifically at trans and non-binary folks, I think it was over half of them report not feeling safe sharing, like being their true selves in public or at work. So it's a huge problem. And it's an expensive problem because it's having a negative impact on what the industry is capable of doing. So what's the source of the problem? And when I have heard that question asked, the answer is always, oh, it's a pipeline problem. It's, there's bias in schools, there's socioeconomic biases. Loads of other similar biases that I, again, feel like is the tech industry saying, it's not my fault. Somebody else did it, I can't fix it. I'll help you by doing a seminar, but it's not my fault. I don't think that that's the real problem. Because there are plenty of folks who have come from hard places and they're smart and they're capable, but when you don't see someone that looks like you or identifies like you up there doing the thing, it's really hard to believe that it's possible for you to do it. So lack of representation is a huge problem. Inclusion. Once someone who looks like me gets to the place and I'm the only one in the room, it's uncomfortable. It's hard to feel included, and it's hard to thrive if you don't feel included. And retention, like lacking those things, people aren't going to stick around. So I would argue that the real problem that we have are like address those three things, and we'll be able to make some headway. Okay, where are we going next? Okay, so any individual can't change the system, but we all have the capacity to do things within our own power to make it better. And so the next little bit is I'm gonna have story time. Thinking back to that list of jobs that I've held, one of them was a wilderness therapist. And at that job, I lived in the woods in structures just like those that we built. Like the process of building it was draw it on graph paper with pencils and like rulers, and then go cut the trees down with hand saws, and then skin the trees and cut them to length, and then make the notches and like build them like Lincoln logs. And it was a month or two long process when your group was running well. We cooked our meals over a fire, and I think I said we didn't have electricity. On really good days, when we got all of our like responsibilities taken care of on time, we might have a little extra time to go climb the live oak trees, and that was like highlight of the day. But on bad days, it was like a bonus if I got to brush my teeth, because there was just too much else going on. That was by far the hardest job I've ever had, and it is the job that I loved more than any other job I've ever had. So I share all of that with you because the skills that I learned at that job absolutely apply to my current job and all the others that I've had in between. And the thing that I'm hoping that I can impart is it's all about skill transfer. So when you are thinking about applying for a different kind of job, or looking at, I'd really love to like do something related to this other thing, but you're like, I'm not qualified. I don't have the things they're looking for. I would argue that it is entirely possible to take what you have and make something out of it that will apply. So, as a wilderness therapist, we routinely did not have enough resources. We had to get stuff done, like building those shelters with a team of moody as adolescents as the people we were working with. Constant unforeseen challenges, conflict, skills gaps. Those kids showed up and had never held a hammer before, and and they were sent there by the courts, and we were giving them sharp tools and knives and things, and it was brilliant. I would go back in a heartbeat. Okay, so of those skills, to translate that to being a software engineer, I learned to think outside the box in really creative ways. Ever-changing parameters, you never know what's coming next. What are you going to do with it? What are you going to do about it? How are you going to move on to the next thing? Most importantly, effectively defining the problem at hand. In any given moment, if things aren't going well, there's a problem. And if you can't define it, and if you can't name it and give it parameters, there's no way you're going to solve it. That was a huge learning. Teamwork, communication, all of those things, conflict resolution, you name it. That all goes into being an effective member of whatever kind of team, software engineering or any other kind. All right, so the next thing beyond your skills is thinking about your portfolio. How are you present in the world? What evidence do you have of what you're capable of? So contributions to open source projects, side projects that you've built just for fun, anything that showcases the skills that you have and how you're using them. You're leveraging these unusual skills in ways that make your contributions to the world evident. So, portfolio, and focusing on problem solving and positive outcomes and accomplishments. Job titles aren't nearly as important as what you did, what mattered while you were doing whatever that job was. Network. So in tech, there tends to be an overloaded, we are heavy on introverts. And as introverts, I am an introvert. It is really, networking makes me nervous. Having to talk to people, it's hard. Gotta do it anyway. There's no getting around that one. You have to buck up and talk to people and network and find connections. Figure out how can I help you with that thing you're being challenged by? Or, I'm learning more about what you're doing and it sounds a whole lot like what this other person is doing, and I feel like y'all should talk. Networking doesn't have to be all about having uncomfortable conversations with people. It's about connecting. It's like humans are neurons, and we're connecting to make something bigger. And the job descriptions. So here's the really, I'm going to call it fun. It's not really fun, but I can't think of a better word. So hiring managers and recruiters are big dreamers. They have fantasies about what exists in the world and what they would like to see, and often they're just not realistic. So for instance, I've seen a job posting saying that they needed 5 to 7 years of experience working with X that had only been in existence for 3 years. So when you look at a job post, don't approach it as all or nothing. It's a general idea. And if you can get close to 60, 70% of what's on there, you absolutely have as good a shot as anybody else, because no, like, job descriptions are written for unicorns and they just don't exist. Okay, let's see. Their wish lists. They don't, like, when, even if someone says that this skill is required and you don't have it, if you meet enough of the rest of it, and you can, and it seems like the sort of thing that you're like, I don't have it, but I've got this other thing that is similar that can transfer, that's a really easy thing to approach them and say, I don't, don't lie. Don't say, yeah, I totally know how to do that. But say, I don't have that, but here's how I learned this other similar thing, and my process was X, and it seems like a transferable skill, so I could get up to speed quickly. So, like, the bottom line here is, don't self-reject. Start out with the attitude of, I could do that, and just go for it. Okay, let's see. Now, this is so here is where I would love to either have any questions anybody has about, going, like, applying for jobs, or where to look, or how to get started, or next career moves, or whatever. Or I have this skill that I feel like, or I need this skill and I'm not sure how to get it, or I don't know, like, I would love to hear if anybody is looking for a job and wants to, like, talk through how to apply, or I know, like, a lot of people are, I'm assuming, happy where they are. I don't know. But I will say, like, if there are folks that have similar stories about skills learned elsewhere, and how that transferred, I would love to hear that as well. So. Sure. Bring it.
So I did not start in tech. Oh, yes, microphone, because this is being recorded, right? I did not start in tech. I actually started in Earth and Atmospheric Sciences. My degree is in meteorology. So I went from meteorology to being a research assistant in a literacy program to going and being, let's see, I had like a whole checkerboard. I call it my checkerboard of experience. Did that, then went over and became a sales assistant for insurance, and then went and became a science educator at a science museum. So I know that outdoor sciencey stuff. And then I ended up as a science editor and a math and science exam editor. I got to take an exam every day. It was great. And then I ended up in tech. And basically, all of it was having no shame in saying, why not? What happens if I just toss my resume at this and find out? So a lot of it is that transfer of skills, like, hey, yeah, I can talk to people. I'm an introvert, but sure, why not? I can talk to people. Do I really want to talk to people? I don't know. I keep telling people, though, one of my jobs is to get up and give a presentation to tech people incessantly. And I always tell everyone, you aren't as scary as 8-year-olds who expect me to blow up a volcano every day. And I actually used that line on my hiring manager when I got my first developer advocacy job, and she thought it was hilarious, and she agreed. So, shared stories. It does happen, and it happens more often than you think.
Awesome. Thank you. You aren't as scary as 8. That's true. I can't think of anything scarier than a room full of 8-year-olds expecting an explosion. Yep.
Especially when the explosion doesn't work.
Yeah. Oh, yeah. I raced through all of my slides because I was, like, making time for interaction. So, but I totally understand if we, yeah. Microphone, right.
So I have a suggestion for Red Hat specifically, but there's stuff like this other places too. Red Hat has this thing called a gig, which I thought was really dumb when they first announced it. I'm like, why would I want another job besides the job that I have? And it's like you can have an opportunity to try working on something else for a while you do your regular job if your manager is okay with it. But we went ahead and posted some gigs to see what happened, and we got a chance to work with a whole bunch of really cool people who had really cool managers who were willing to let people branch out and grow. And, you know, they might end up transferring or they might end up just being more satisfied where they were. And we got a lot of good help on what we were doing. I'm in the research group, so we have a lot of flexibility, which helps. We don't have a product deadline, but so I would really recommend that, even though it sounds kind of lame when you read it on the HR website. A lot of other companies do similar things, and even if they don't, you can like go to your manager and say, "Hey, I've been working 60 hours a week. I'd like to take, 8 hours a week and work on this other thing, and how could we work out a way to do that?" And most managers, like if they have any of your interest at heart, they'll negotiate and they'll figure out a way to do it. So that's a good way to transition.
Awesome. Yeah, thank you. Major.
So I guess as someone who's gone through the introverted to somewhat extroverted transition, I think the one thing that helped me going through my career was sometimes when I found it hard to talk to people, I would offer to help with something. So instead of like, it's not me directly talking to the person, now we're talking about this other thing that's broken. And so that was something that's always fun for me. I fell into tech on accident. I wanted to go to medical school, and I had 81 rejection letters over a period of 3 years come in. And that was challenging. But I think the one thing that really got my career started was I got a really, really terrible job making minimum wage doing some tech stuff, just very light tech stuff, literally managing one server. And then finally I asked people, I said, "Hey, what kind of code are y'all writing?" And it was like classic ASP. I don't know if anybody's written classic ASP in the old days. Ugh, it's nasty. And I'm afraid, yeah. But I ended up helping and ended up contributing some stuff. And I don't know, it opened the door to like 100 other things.
Yeah. Absolutely. Offering to help is key.
I'm just going to tell a story. I don't know how much it pertains, but I was thinking back to your slide at the beginning, and talking about, who's at the job. So for me, I find that can really wear masks really well. And so I really like the job I have right now because I'm working with the kind of people I want to be working with. But I always counted it among my strengths to be able to work with anyone. And I just that the choices in my career have usually been around, focused around things like burnout and unhappiness. I've lived as an artist. I can live lean if I'm happy. And so maybe that's just my comment is that finding the people you want to work with and working with them can be so important, so much more than the number, maybe.
Yeah. Thank you very much. I appreciate you sharing that. All right. Anybody else? It's been a long day. It has. And I bet the exhaustion is.
I have a
yeah.
hard question.
Okay,
because I came to this thinking that this is in a way we were going to be talking in one way or another in relation to the climate change around DEI. And I always like to ask, I think of hard questions. As an engineer, I think about how things fail. I think about worst case scenarios. So it's a tough question, but maybe, and I won't necessarily put you on the spot with it, I might put us on the spot with it. But it always struck me as the most difficult thing was, well, what do you do if the clients are discriminatory? What do you do if the marketplace is discriminatory? So, I've always said, hey, how come we don't have more diversity here in the part that we do control, and then the question might be, well, it turns out that we sell to a market that is maybe really behind the times when it comes to what's really going on. And I don't have an answer to that, but I always like to bring that up to say, like, I feel like that's what we're up against. That if any one of us were to say, we're gonna broaden our concept of who we want to hire, we're gonna broaden our concept of who belongs here, and all that, you know, we might be dealing with a marketplace or you know, that says, like, no, we're the ones telling you we don't like that, you know. And to me, it's always just been a very brave act then to show up as myself, to try to say, hey, maybe you should consider that there's more going on with y'all than you realize, that you would gain some advantages to seeing yourself and the things that you do more. But it seems like it can be a tough sell. I don't know if there's any comment to be said about that, but that always struck me as the hard part is it's a very vulnerable act, you know, to grow and to change, and that we might be leaders, and then that means that the people we're trying to lead, you know, they're not going to be pulling it out of us. We will be changing it for them.
Yeah, that is a really hard question, and I don't have an answer. I don't have like a wrapped up answer in a package for you, but the way my brain works is, like, I think about individuals as members of a system of people in a kind of the same way that a company is like an individual in a system of companies. And I think that we can show up and be the representation in the room, so that, you know, we are there at, you know, like, showcasing what is possible, and theoretically, you know, some organizations are gonna, like, not even notice. Some organizations are gonna be like, well, they figured it out, why can't we? And follow the lead. And some organizations are gonna be mad and take their ball and go home. But I would hope that we collectively show up as the, you know, the representation in the room as best we can, and make the world a better place, slowly and painfully.
Thank you.
Yeah, so I don't have such a interesting background as you guys, but I did the more traditional, got a computer science degree, went into high tech, stayed in high tech. But I really like the picture you showed. I tried to do a similar picture and got mostly guys in suits and stuff. I'm like, wait a minute, software engineers don't wear suits. But then I wonder, who trained that model? So is it just like this perpetuation of biases?
Yeah.
And so I had a fun time arguing with my AI to get a picture. I'm like, put t-shirts on these people, like, show more women, show some older people, show some people with white hair. It's like, so I tried to get like a really diverse picture of people. It was really interesting.
Yeah, I've absolutely argued with it about that kind of stuff, and like instead of like giving it more specific instructions, I've called it out. I've been like, "You're perpetuating the bias," and it's like, "You're right, I am."
Yeah.
Like,
God.
It was Gemini.
Very complimentary. Yeah.
Yeah.
Well, I have a response to that. Sorry, I'm making you run for it. So, couple things. One, if you have not watched, there is a wonderful talk. I think it was given at a lead dev conference. A researcher went through and talked about the systematic bias in visual models specifically. This was like 4 or 5 years ago, so it's not during the current crop of AI models. But they were showing how, because of the way the training sets were put together and how old some of them were because it was in public domain or this or that or the other, that helped perpetuate some of these stereotypes that we see everywhere, because they're trying to take pictures of this and that, and then you know, there were other things that were not great about these models. You probably have heard about it from some of Google's stuff, because I think some of them were coming out of Google's research arm on AI and ML at the time. So highly recommend watching it. Really, really good talks. It wasn't TED Talks. I'm pretty sure it was lead dev. It might have been Ada or Grace Hopper. I can't remember which one, but highly recommend going to see that. And also, apparently arguing with the LLM is actually making it worse or something. So Ars Technica had a really great talk on that. I just want to kind of come back though to the system question, and you're kind of mentioning the systems idea, but system science says that if you go through and you start to see changes in little bits of the system, it's going to eventually perpetuate throughout the system. So even if small pieces change, you've already changed the entire system because of the way that everything works. So it's never going to be the same the more that we do little things. So when we talk about what power we have, it has more to do with start where you are, because you might not be able to influence everything, but you're already influencing things because of the way that systems theory works. So in case that kind of helps a little bit, provide a little bit of scientific grounding, I will get off my nerdy scientist soapbox now.
Thank you so much.
Oh yeah. To that point, not sure the TED Talk, but there's a book and like a Netflix documentary that I believe I watched. It was Coded Bias.
Okay.
I believe from a few years ago.
Okay.
And that was really, this is pre-Gen AI boom. This is talking about computer vision and facial recognition software, and how some folks were being misclassified as criminals just because there wasn't a representative sample in the data set. Or the sample that was represented in the data set were associated with criminals. So it was a lot of misclassification. And the other is, I think, Weapons of Math Destruction. Really good book.
Okay.
It talks about like the algorithms and all the bias and like, you know, everything behind it. So yeah.
Excellent. Excellent. Thank you so much.
Mm-hmm.
I have like a reading list and a viewing list, and I'm gonna be busy. Love it.
All right, quick thing for me. One more thing on the extrovertedness. If you have trouble doing it in large groups, I think one thing that helps is always having a mentor, and always having a mentee. And I've heard so many people tell me, "Oh, I can't mentor somebody. Like I don't know enough to do that or whatever." And I was like, no matter who you are, even if you're a junior person that just joined a company, you can mentor someone. Even if you're a college student, you can mentor someone else. Like there's no excuse. And it's a really good way to have that one-on-one conversation. It might help you branch out to bigger things.
Yeah. Good call. Awesome. All right. Last call. Anybody?
All right.
All right.
I don't know, say something, but I like how you framed this as a skills transfer problem rather than a pipeline or ladder climbing problem. Because to me, like my personal experience has always been like every job I've ever applied for, like I'm grossly underqualified for. And it's also funny to me being on this side of the fence. Like a lot of times I will read job recs for people into my team. And I'm like, I couldn't even get that job. Like, and I'm like, I'm literally doing the job. So I've always felt there's a huge disconnect between this. I find those descriptions, the job requirements, to be super discouraging because I'm like, I feel like I'm capable, but I don't think I meet these standards. So just as an encouragement to go apply anyway. And then like, as far as like, again, I like the skills transfer thing. One of the reasons I love working in open source and Red Hat in general is the communities. And my job as a participant in a community, and even if I end up having like a leadership position or a position of influence in a community, I have a responsibility to make that community inclusive and safe. And even if I can't change the world, I can change my little corner of it. And you better be darn sure that my community is going to be inclusive and accepting and open, because it makes everybody better the more people we have. And the more voices we include and the more people we encourage to join. I've personally benefited from a lot of input and mentorship. And so I just do my best to everything that has been poured into me to pass forward. As many people as I can get to listen to me yakking, I will talk to you all day about anything you want to talk about, because, you know, sharing is caring. But anyway, I just like the whole notion of like skills transfer is how we help people. And I'm like, that's sweet. I like talking to people about nerdy tech things or just whatever. So just the more we share And the more we make people feel included and welcome, and there's no dumb questions, no judgments, and and stand up and call out behavior like that when you see it. Say like that's not appropriate. Let's not treat people that way. You don't have to use like feel good buzzwords. Just be like, just don't be like that. Like no, that's not how we roll here.
Thank you so much. Thank you so much. And I really appreciate the discussion. It's like we're out of time. I don't know, the buzzer's like blinking at me, and I don't know what that like. Y'all are welcome to. It's fine with me if you stay, but mostly thank you. And Sam, like what you just shared, like absolutely ties in with what you shared, and your name has escaped. Laura shared about like a tiny change in a system